Muy buenos días a todos y a todos. Good morning, everyone. Welcome to. Soy Gabriela Cortés, periodista del Centro de Investigación para la Gestión Integrada del Riesgo de Desastre, CIGIDEN, y les quiero dar la bienvenida a nuestro Seminario Internacional Resiliencia Transpacífica, actividad que hemos organizado en conjunto con el Centro para la Resiliencia Sísmica de Nueva Zelanda, Quakecore. A continuación vamos a invitar a nuestro director ejecutivo, Stefan Vogel, para entregar unas primeras palabras.
Muchas gracias, Gabriela. Buenos días a todos y todas. Gracias por estar acá, especialmente al señor Michael O'Shaughnessy, encargado de negocios de la Embajada de Nueva Zelanda. Gracias por estar acá acompañándonos. Obviamente a todos nuestros colegas de Quakecore que nos han acompañado en los últimos días, y los colegas de CIGIEN, bueno, y todo el público que nos acompaña hoy día en esta celebración de este trabajo en conjunto entre Quakecore y CIGIEN. Yo tengo que pedirle disculpas por dos cosas. La primera es que parece que ojalá que sea algo de alergia, me duele un poco la garganta. La segunda es que tenía algunas palabras preparadas, pero dado el terremoto de ayer de Taiwán, la verdad es que voy a improvisar, ¿ya? ¿Por qué? Porque frente a ese terremoto surgió algo en mi cabeza que es, tenemos que tener mucho cuidado con la tendencia a gestionar el último desastre. ¿Qué quiero decir con eso? Obviamente tanto las inundaciones como los incendios de viña que vimos a principios de año fueron desastres terribles, con más de 100 pérdidas humanas y pérdidas materiales también que todos conocemos. Y por supuesto, tenemos que entender, tenemos que estudiar, tenemos que saber qué falló. Obviamente no es con la idea de apuntar con el dedo, no es para nada nuestro rol, pero sí aprender, sí saber y mejorar de tal manera que podamos ayudar con conocimiento a evitar que algo como eso, un desastre, porque eso realmente fue un desastre, se vuelva a repetir. De hecho, hay un equipo de CIGIEN en este minuto que está en Viña del Mar. Sin embargo, no debemos olvidar, no debemos caer en la tentación de poner todo el foco en el último desastre, en los incendios. Tenemos que gestionarlo, tenemos que avanzar en eso estamos. Tenemos proyectos orientados a la gestión del riesgo de desastre de incendios, de inundaciones. Pero no olvidemos que Chile es un país sísmico, no olvidemos que Chile es un país sujeto a la amenaza de tsunamis. Hemos avanzado muchísimo desde el 2010, por nombrar algunas de las áreas en alerta temprana, en la preparación de la población, en las normas sísmicas, sin lugar a duda que hemos avanzado. Pero quedan muchas áreas en las cuales todavía tenemos que avanzar. Solo un botón de ejemplo, lo hemos dicho en reiteradas ocasiones, un tsunami de las características de 1730 en la región de Valparaíso actual sería un desastre de proporciones. Hay mucho que tenemos que hacer todavía en esa área. Y, esa es la introducción, es decir, tenemos que aprender de otros, de sus aciertos y también de sus errores. Por eso nos acompañan hoy día Quakecore. Y es bastante interesante cuando yo digo que es un país largo, flaco, que está en el Pacífico, al sur, que está en una zona de subducción, con volcanes y sujeto a la amenaza tsunami. Probablemente no saben si estoy hablando de Chile o de Nueva Zelanda, porque tenemos todas esas características en común. Y todo eso obviamente nos lleva a habernos juntado durante 2 días con nuestros colegas de Quakecore. Y después de esas reuniones yo me quedo con un problema y con una pregunta. El problema es que cuando listamos los puntos que teníamos en común, lo hizo acá nuestro colega Juan Pablo, que está por ahí, no sé, eran más de 30. La verdad es que tenemos tantos puntos en común que parece difícil saber por dónde comenzamos. Yo creo que es un problema, pero es un excelente problema. Ahora, sí, tenemos un plan de acción y vamos a poder comenzar y vamos a seguir avanzando. Y quizás la pregunta que tengo en mente es, ¿por qué no lo hicimos antes? Dado todos estos puntos en común, dado las características, dado los equipos de investigación, esta misma reunión debimos haberla tenido 5 años atrás. Pero bueno, se dio ahora, y bienvenida sea. Y lo importante es que ya tenemos un plan de acción, levantamos todos los puntos que tenemos en común, que son muchísimos, como dije, y nada, agradecemos el interés que tuvo Quakecore, la delegación de Nueva Zelanda, en nuestro centro de investigación y en nuestro país. Así que sean más que bienvenidos en esta cooperación. Y sin más, dejo al señor O'Shaughnessy para que nos dé algunas palabras de bienvenida. Gracias.
Hola, buenos días. Soy Michael O'Shaughnessy, soy el encargado de negocios de la Embajada de Nueva Zelanda acá en Chile. Y realmente siempre un gran placer estar acá en la Católica, una universidad muy importante e influyente tanto en Chile como en todo el Asia-Pacífico. Pero también es un placer, gracias Stefan y el equipo de Seguiden para la invitación a este evento tan importante, porque como lo ha dicho Stefan, que lo que Chile y Nueva Zelanda compartimos en común son muchísimas cosas súper buenas, la geografía, la diversidad de la geografía, muchas veces la manera de llevarnos como sociedades, etcétera. Por eso tantos chilenos se encuentran muy cómodos viviendo y trabajando en Nueva Zelanda y nosotros kiwis en Chile. De hecho, acá les llamamos los kiwis que están acá, los chiwis, etcétera. Y tanto en común tenemos. Y claro, como lo ha explicado Stefan, es que tenemos muchos desafíos en común. Y eso de los desastres y las emergencias, etcétera, es uno de ellos. De hecho, tenemos en Chile, de hecho, hoy en Rapa Nui, en una cumbre sobre la contaminación de microplásticos, tenemos nuestra asesora jefa de ciencias al primer ministro, la Dame Juliet Gerard, que compartió el avión de venida de nuestro equipo de Quakecore. Y ella, el lunes estuvimos con la ministra de Ciencia, con ANID, con el Consejo Nacional de Ciencias, hablando de tantas cosas que tenemos que trabajar juntos con Chile, porque compartimos no solamente las cosas en común, pero también los intereses en común y también la necesidad para formación y capacitación humana para nuestro propio desarrollo, el uno y el otro. Y uno de los temas, las áreas que enfocamos era precisamente en esto de la gestión de desastres y emergencias, especialmente construyendo la resiliencia, pero también la reconstrucción después, porque compartimos muchos de los mismos desafíos. Chile, claro, para Nueva Zelanda es, bueno, ayer tuvimos el privilegio de reunirnos con el presidente Boric y el ministro de Asuntos Exteriores Van Claveren y le dijimos que Nueva Zelanda, para Nueva Zelanda, Chile es el país más, lo que llamamos like-minded, parecido en disposición y con eso de todas las prioridades sobre la democracia y derechos humanos, pero también todo lo que va con el desarrollo más amplio. Y con él hablamos de cómo Chile siempre para Nueva Zelanda es la puerta de entrada para toda América Latina, porque es el país acá que tenemos más años trabajando juntos y más flujos de nuestras poblaciones el uno al otro. Y este seminario con QuakeCore, que es un centro de excelencia de investigación en Nueva Zelanda, que es muy importante, que trae muchos grupos, especialmente de las universidades. Acá tenemos la Universidad de Auckland, de Massey y de Canterbury. Todos tienen rankings muy altos mundialmente, pero especialmente lo bueno no son solamente los rankings, que son simplemente números muchas veces, pero es la sustancia. Y eso es lo que enfocamos, y lo que me gusta sobre QuakeCore y el trabajo que hace es que se enfoca en lo práctico. Aprovechan de los conocimientos intelectuales y académicos para explicarlo para el bien de la sociedad y para el futuro. Y seguramente eso es exactamente uno de los 30 puntos en común coinciden, y les deseo un seminario muy aprovechoso y miramos con ganas cómo desarrolla esta relación tan fructífera. Venga, muchas gracias y buenos días.
Muchas gracias por sus palabras a Stefan y al señor Michael. Ahora quiero dar paso a las presentaciones de QuakeCore, especialmente de Liam Witherspoon y Catalina Miranda, que nos harán presentación en torno a las oportunidades de becas para estudio de posgrado de Nueva Zelanda.
Ok. Hola, soy Liam. Mi español no es bueno, así que voy a presentar en inglés. So, hopefully it comes across very well. I apologize for my horrible pronunciation. So, I'm here today to present on behalf of Te Rangaru QuakeCore, which is the Aotearoa New Zealand Centre for Earthquake Resilience. Aotearoa is the Māori word for New Zealand, the indigenous peoples of New Zealand. So really happy to be here today to give you an introduction of some of the work that we're doing. So I thought I would bring this up. There's been a lot of discussion in the first few presentations about the relationships between Chile and New Zealand. And of course we can see here the map of the world, and we have Chile and New Zealand sitting in the Pacific Ring of Fire, meaning that we have many earthquakes to deal with, tsunami to deal with, and many volcanoes to deal with. So in a geologic sense, very much we are facing the same sort of perils and the same sort of issues. So, and also, we're neighbours across the Pacific in terms of where we're located. So it's really great to be able to be here and discuss with Sijiden about our common needs and requirements and research. One other thing that we share when we think about earthquakes is subduction zones, right? And the subduction zones are a really key focus for Chile, and they're a really key focus for New Zealand because they make up a big part of the source of the hazards that we have to deal with. And again, you have a big subduction zone, yours is bigger, ours are smaller, but we have two. So we face interesting aspects in terms of our hazards. New Zealand sits on that plate boundary, and we have a very complex tectonic setting. If we look at the figure here, we can see the map of New Zealand. The red lines on shore represent all our crustal faults that we've identified, and this is really the history or all of the earthquakes we've experienced in the past have really come from earthquakes that have occurred on those faults. So we know a lot about our crustal faults. We also have those two subduction zones, those simple lines on this map offshore give you an idea of the location, but they're much bigger and they extend under the islands at either end. And as you can imagine, or as you can see from this cutout figure, one dips down in one direction and the other dips down in the other direction. So those plates are really trying to tear us and push us and move us around as much as they can, and it makes for a very interesting system when we think about how those two are connected. So we know very little about our subduction zones. If we look back to the past, we have a very small understanding. We haven't experienced, or we haven't really seen the broader implications of a big subduction zone earthquake. That's very different to Chile, who know a lot about their subduction zone, but maybe perhaps about some of the crustal faults. So you immediately see we have a lot that we can immediately learn from each other of the experiences of these different types of earthquakes. Of course, we mentioned tsunami. So when Chile has an earthquake, they give us a tsunami. So we're very geophysically connected in that way as well. So as you develop and learn more about the subduction zone and the tsunami that it produces, that really comes to us. The better you constrain and understand your hazard, the more we constrain and understand our hazard and the potential implications. So as has been described by the previous two speakers, we are connected in many, many ways. So it's really, really great to be here because of that fact. So both countries have very similar hazards. We have many earthquakes, we have tsunami, we have many volcanoes, as well as extending beyond the geophysical to the other things that we are dealing with climate change, flooding, landslide on roads. We have seen that very recently in both countries as well. So we come here talking about earthquakes and tsunami, but we have a much broader link and a much broader opportunity to work together across these wider suite of hazards. So the way that I describe New Zealand, and then after being here, the way that I can describe Chile, is we are both a very chaotic country. But because we are both chaotic, we are both very beautiful countries in terms of the landscape is beautiful because of the chaos that is always going on, evolving and developing that landscape. So, if this works, you can work out if this is New Zealand or Chile. Hard to tell sometimes. So if we looked at just the landscapes there's lots of very similarities in the landscapes. We also both enjoy wine, which is good too. So we have this chaos, we have these beautiful landscapes, we accept the chaos and we want to live in our countries, but we will then also want to ensure that we can move and develop the resilience to try to deal with these events, because we want to stay here, we want to live here, we want to enjoy this, but how can we ensure that looking forward, dealing with the events that we know are going to occur, that we can deal and manage and plan for those events to ensure that we minimize the effects. So if we think about New Zealand and where Quake Core emerged from, it's a very similar story to how we have described how Sijidin emerged from. Big events that faced the country. So in 2010 and 2011, we had the Canterbury earthquakes in the South Island of New Zealand. They were The main earthquake, the Christchurch earthquake, was actually a relatively small earthquake in the magnitude scale, 6.2. But because it occurred directly under the city of Christchurch, the impacts were significant. So 185 lives were lost, a significant impact economically, so about 50% of New Zealand's GDP was the estimate. It's probably bigger than that now. But 70% of the central business district of Christchurch was demolished. 70% of the buildings were demolished. So significant impact in terms of damage. There was liquefaction or loss of strength of the soil in the large part of the residential area, meaning that 50,000 homes were really significantly impacted, and some had to move away completely. Huge amount of impact really of that event, and you can see Christchurch now is very different to Christchurch prior to that event. So that was really the trigger for us to say we really need a more coordinated approach within New Zealand to try to deal and manage the seismic risks. So Quake Core evolved from those thinkings and started in 2016, at the start of 2016. Hopefully the start of Quake Core wasn't the trigger for the Kaikoura earthquake, but very soon after 2016, at the end of 2016, we had the Kaikoura earthquake in New Zealand too, a much larger earthquake, magnitude 7.8. A lot less impact on populated areas, but significant impact on infrastructure. So our infrastructure networks, we have very long, thin country, we have very few roads, very few alternate routes on those roads, very similar to Chile. But we had the closure of our main north-south road and rail corridor for over a year, which had significant implications. There was quite significant damage in our capital of Wellington, where there was some level of amplification of the shaking. It's in a basin of soil, and that really only impacted larger buildings, so commercial buildings, where most of the residential buildings were not impacted. So that, an event that affects your capital city, and then an event that affects your networks, really triggered and identified and showed to us we were heading down the right path when we were thinking about research. So this has been another key event that has underpinned Quake Core's sort of scope and drive to look broad across the different impacts of these events. So what is Quake Core's mission? Very similar to Sejuden's mission and the description provided earlier. Transforming the earthquake resilience of communities and societies through innovative world-class research, education of the next generation, and deep national and international collaborations. And the last line is why we were here today over the last few days, and why we're really seeing the potential benefits we can have moving forward working with Sejuden. So I'm going to provide an overview of the structure of Quake Core so you can get an idea of the breadth and the depth of the research that's going on. So most research programs have this very nicely typeset and presented representation of the structure, and really I'm just going to focus in on these disciplinary themes and interdisciplinary programs. Just to give you an idea though that Quake Core was structured to be very multidisciplinary. So we have representation in terms of our research team from across all of the different universities of New Zealand into different research organizations, and that cuts across everything from the geology and describing the hazard at the start through to the implications and the engineering aspects and into the economic and the social implications and the decision-making about what we do. So it's very multidisciplinary in terms of its focus. And we do this on purpose because by taking the approach, which is sometimes difficult because we often speak different languages, even within New Zealand, across different programs. But this is where the really amazing and interesting and new and innovative research can develop. So our disciplinary themes look deep into the topics, while our interdisciplinary programs bring in people from all sorts of areas together and try to develop and foster and emerge how do we cut across these different knowledge areas. So I'm going to run through these quickly. The leads are the nice photos at the top, just to give you an idea. You might see a few of the faces in the crowd as part of these. And I'll run through the disciplinary themes first and then the interdisciplinary programs afterwards. So the first here is our integrated seismic geohazards. This is at the start. We often describe it as once the fault breaks, then the first implications of once that fault breaks or ruptures. So we look at really high resolution models of how the shaking varies away from the fault. We look to then improve our understanding of how soil performs, and liquefaction is a really key aspect as part of our research. And then, as described, landslides are a really important piece of that puzzle too. So how do we improve our representation of all those to tie them together so that we can start to make predictions of 4 different events that we see in New Zealand? What is the broader scope of the geohazards that we might face as the first piece of that puzzle? That then feeds into the implications from that point onwards. Our second theme is very much for our structural engineers, right? So our structural engineers, whole of building seismic performance. This is really about thinking about buildings and their systems as we build up our understanding from the different pieces of the buildings to how they work together and move together, not just the structural or the structure that gives it the strength, but all the pieces of the building that make it a building that we can work and live in as well. So modelling, observations of earthquakes, both in New Zealand and internationally, to tie those all together. How do we improve design to help support improved performance? So that's the scope of DT2. Oh. DT3, law, planning, and economics. So now we shift in this area to focusing how do we develop the systems, or how do we better understand the systems that enable or support or allow us to actually move forward with making decisions in terms of our support of our seismic resilience. So from governance and the tools that governance use to help incentivize some of the things that we can do, are there economic ways that we can incentivize to really translate from this is what we've worked out in research, how do we put that into practice, right? And so by putting that into practice, that's where the rubber hits the road. That will help us to support and inform effective risk reduction. DT4 is really focusing on people, right? And so we move to social science and really trying to delve into getting a better understanding of how both different cultures in the context of New Zealand and broader, and the social implications or social factors that we can help improve resilience, right? So it's less about the physical and more about the people and what people can do. So how do people behave? Looking at videos at earthquakes and doing different modelings. How do people think about risk and understand risk? That can help us to inform how we convert what we've done out to the real world and help people understand and make decisions, and how we can help to incentivize again in a personal context to get people to think about resilience and make themselves more resilient. So this is really about behavior. How can we influence and support and understand behavior, right? We need to understand people because that's really why we're doing all this. It's for the people. And our last DT5 focuses on Māori. Mataranga Māori is Māori knowledge. As I said before, Māori are the indigenous peoples of New Zealand. So we really bring in the contexts of how the Māori world, what that perspective looks like, and how the perspectives of the Māori world change the way that we approach resilience. This is both to bring together Western science with this Māori knowledge to further involve the approaches and understandings for us to deal with seismic resilience. So a lot of this work is very much working with communities, developing capacity, tying together different aspects, as I said before, and that ensures that when we try to identify these solutions are going to be appropriate for Māori, they're going to be appropriate more broadly. And so that is a key focus in New Zealand, is the greater seismic resilience for Māori. So those were the 5 disciplinary themes that really focus in detail. The next are the ones that cut across a range of disciplines. So the first is called functional recovery of multi-story buildings. The idea behind this is, in the past, a lot of design has been about just life safety. Let's ensure that we design things so that after an event, people can get out of the building and they're going to prevent injuries, prevent fatalities. This is a good target to have, but we want to move that further. We want to be able to ensure that we can have buildings that survive, and then after the event, they can still be used, right? And we see even examples of that in New Zealand. So the idea behind this is to cut across understanding both the structural design, the process of going through repair and the different physical aspects that control this, and then the timeframes for restoring building function. Thriving residential communities focuses on communities. So this is where we bring together the legal and planning aspects I talked about before with different low-cost solutions to bringing in our understanding of the perspectives of what residential people need and require, to tie that together to identify how we can have solutions that support housing and infrastructure resilience. The third focuses on the transport system. This is bringing in models of the transport system alongside both, again, the expectations of the users of the transport system, so what does the community and the users need and want, and how we then ensure that after an event, there's ways that we can ensure that we bring those systems back online. So this really enables the resilience of both the transport system, but also the users on top of that system. And then the last but not least, harnessing disruptive technologies. So this is really looking at, as we see changes in the systems that we have, so different energy systems, for example, different telecommunication systems, things like electric transport and autonomous vehicles, how when those are coming through, how does that influence our resilience? Does it improve it? Does it degrade it? And how does that change over time? So this helps us to look not just at now, but looking out 30, many years into the future and what that means for resilience. So that's the scope of the program, and we're here today to say that there, as has been described, there's plenty of opportunities for research. There's plenty of opportunities for research exchanges, and for the students in the audience, we would love to have you over in New Zealand to work together alongside Sijiden to understand how we can develop both solutions for New Zealand and for Chile that are going to work together. So, si vienes a Nueva Zelanda, lo vas a pasar chancho. Muchas gracias.
Hola a todos, soy Catalina, soy chilena, así que pónganse, put your, I don't know what the name of the thing is, but yeah, there we go. Soy chilena y vivo en Nueva Zelanda. Me fui a vivir a Nueva Zelanda hace un poco más de 6 años. No voy a hablar nada técnico, les voy a contar mi experiencia en Nueva Zelanda y a ver si los motivo para que se vayan para allá. Le voy a preguntar esto a los chilenos que están acá. ¿Ustedes cuál creen que es Chile? ¿El de allá, el de la izquierda o el de la derecha? ¿Quién dice izquierda? ¿Y quién dice derecha? Oh, como la mitad. Bueno, Chile sí, no. ¿Cuál es Chile? ¿Lo de Nueva Zelanda? Este. ¿Por qué? Bueno, quizás no debería decir esto, pero ¿por qué el camino está más trabajado? Y allá tenemos un departamento de conservación que se preocupa mucho de la naturaleza. No es que aquí no tengamos nada, pero hay que trabajar un poquito. Así que se parecen mucho, tenemos los mismos, tenemos muchas plantas y animales, porque tienen muchos pajaritos. Pero esto como que, no sé. ¿Me escuchan ahí? No. La siguiente. Bueno, y esas son las cosas que tenemos similar con Nueva Zelanda. Hay algo muy diferente que me llamó mucho la atención, que descubrí cuando me cambié a Nueva Zelanda, es la colaboración entre las universidades. Allá las universidades en general, yo podría decir que no compiten mucho, más colaboran entre ellas. Cuando yo hice mi doctorado allá, tuve la oportunidad de trabajar con profesores de otras universidades y conocí a muchos estudiantes de otras universidades. Y también, no solo las universidades, pero Quaker se encarga de traer a la industria. Entonces las conexiones con la industria son mucho más fáciles. Lo que uno investiga es más fácil que se vea reflejado en la práctica. Yo hice mi doctorado en la Universidad de Auckland, la que estaba ahí arriba, y después el doctorado me llevó a conocer a mucha gente y terminé ahora estoy haciendo mi postdoctorado en la Universidad de Massey. Bueno, un poco acerca de mi carrera para que ustedes vean que es posible. Soy de Concepción, de la Universidad de Concepción del Sur, y hay con unas fotos que me mandó mi papá de cuando yo estaba haciendo los test en la Universidad de Concepción para mi tesis, y no sabía que quería hacer mi doctorado. Después trabajé durante 3 años en Chile como ingeniera, y después descubrí que no era para mí, así que busqué opciones y encontré opciones en Nueva Zelanda. Y hice mi investigación en la Universidad de Auckland, como les dije, financiada por Quaker, por una beca de allá, por 4 años, 4 years, yeah. Le estoy preguntando a mis supervisores porque ya no me acuerdo. 3 de mis supervisores están acá. Y en mi investigación de doctorado, aunque yo soy ingeniera, tuve la oportunidad de mezclar más áreas social. Y como les decía, ahí existe la posibilidad de colaborar con otras universidades y con muchos otros profesores. Entonces, una de mis supervisoras que está acá me llevó también a trabajar en el área social. Y investigué qué es lo que la gente piensa que va a pasar en sus casas de madera, que en la ciudad de Wellington, en la capital de Wellington, pero también hice modelos numéricos de las predicciones de ingeniería de qué es lo que va a ocurrir en sus casas. Y comparé las dos y vi que estamos muy lejos de, en verdad, la ingeniería está muy lejos de lo que las personas creen que va a ocurrir en sus casas. Bueno, y durante el doctorado, una parte muy importante para mí, y sigue siendo muy importante para mí, son la gente que conocí y los compañeros que estaban haciendo el doctorado conmigo. Quaker tiene un centro tiene como grupos de alumnos y grupos de investigadores que nos dedicamos, que nos juntamos todos los meses y hacemos actividades, hacemos charlas, y tuve la suerte de dirigir ese grupo de estudiantes por 2 años, y estuve involucrada con ese grupo de estudiantes por 4 años. No, ahí tengo que decir que no solamente hice cosas técnicas, pero también hice amigos, que siguen siendo amigos hasta el día de hoy. Y no solo de mi universidad, como nos conectábamos online, también tengo amigos de otras universidades y que hasta el día de hoy somos compañeros y trabajamos juntos y nos apoyamos, y en verdad es genial. Aquí más fotos La foto del lado de allá es un evento que hicimos con las mujeres en ingeniería en la junta anual de Quakor, que Quakor está haciendo mucho trabajo o tratando de hacer algo para traer más mujeres a la ingeniería. Bueno, tratamos igual. También tuve la suerte de, ¿cómo puedo decir esto? Hacer una presentación. ¿Cómo? Sí, como que tuvimos la oportunidad de aprender cómo los bailes maorí y cantamos en maorí en una conferencia, algo completamente nuevo para mí, pero lo hicimos con mucho respeto y como que eso hace que uno sienta que uno pertenece un poco más. Y una parte muy importante que quería destacar es el apoyo de Quakor durante la pandemia. Nosotros nos juntamos mucho, aunque no nos podíamos ver en persona, tuvimos muchas reuniones online y actividades, no solo de presentaciones, pero también juegos online, y Quakor nos apoyó demasiado durante la pandemia a los estudiantes. Yo creo que todavía me veo las consecuencias en alguno de la pandemia en la educación, no solo en Nueva Zelanda, pero en Chile, pero con el apoyo de Quakor y de las universidades, yo creo que vamos saliendo de ahí de a poquito. Además, algo que pensé mientras Lian estaba presentando es que como un reflejo del apoyo que recibimos desde las universidades y de Quakor, es que durante la pandemia nosotros los que estábamos haciendo el doctorado, Quakor nos ofreció una extensión de 6 meses. Aunque tú, por ejemplo, seguiste trabajando en tu doctorado o estudiando, ellos igual decidieron financiar 6 meses más y las universidades igual ofrecieron una extensión, porque obviamente uno no trabaja al mismo ritmo que uno estaba acostumbrado. Bueno, más fotos. En mi doctorado tuve la oportunidad y todavía de presentar mi trabajo en diferentes conferencias, por pósters, como afiches como ese, y presentar no solo a estudiantes, pero presentar a la industria y qué sé yo. También tuve la oportunidad de enseñarle a niñitos de 4 años hasta, no sé, 12 años acerca de los terremotos, cuando hacemos actividades en los colegios y cuando hay ferias de educación, y etc. Bueno, y más fotos de actividades de entretención. Bueno, como les contaba, me fui de Auckland a Wellington a hacer mi postdoctorado. Y en mi postdoctorado hago un montón de cosas, un montón que ustedes pueden leer ahí, como un montón de proyectos, pero uno de los proyectos es traer a la delegación de Quakor a Chile, iba a decir a Nueva Zelanda, pero no, de Nueva Zelanda a Chile. Me toca hacer proyectos de investigación y tengo que ayudar a estudiantes, a hacer un poco de, ¿cómo se dice esto? ¿Clases? ¿Hacer clases? Así se dice. Hacer clases. Y bueno, y ahí me ha tocado trabajar y conocer un montón de gente en la industria, y yo creo que con todos los de Quakor que están acá sigo trabajando incluso después de mi doctorado. Cosas que me gusta hacer en Nueva Zelanda, salir a caminar, salir a hacer trekkings, como caminatas en la naturaleza. Allá el país está muy preparado para eso, así que completamente lo recomiendo. Si a uno le gusta la naturaleza, salir a caminar es muy fácil. El fin de semana antes de viajar a Chile subimos un volcán con unos amigos, esa foto que está ahí. Igual estuvo difícil, un poquito. También he encontrado mi familia, que les digo que son mi familia, en Wellington y en Auckland. Creo que he tenido mucha suerte. Siento que ya los alumnos internacionales son bienvenidos, y no es difícil hacer conexiones que sean como de, no sé, bueno, conexiones importantes. No puedo decir, no me acuerdo la palabra en español. Duraderas, gracias. Y también pertenezco a un grupo de respuesta de emergencia en Wellington, en donde he estado entrenando por un año para cómo ir a ayudar a la gente después de cualquier emergencia, sea terremoto, tsunami o incendio, etc. Esa ha sido una experiencia muy, aunque no es parte de mi trabajo, me ha mostrado cómo responder a desastres naturales desde otra perspectiva, porque ahí hay que trabajar con la gente directamente. Bueno, eso somos nosotros ayer en el, ¿cómo se llama? El Costanera Center, para que nos vayan conociendo un poco y ojalá puedan conversar con los académicos que están acá, y yo feliz de responder preguntas de lo que ustedes quieran, si tienen ganas de ir a Nueva Zelanda, y de verdad no tengan miedo de ir a acercarse a los académicos, porque más que académicos yo diría que somos todos amigos después de este viaje, ¿no? Bueno, y antes del viaje igual. Así que nada, eso. Gracias.
Gracias por las presentaciones. Antes de seguir con el bloque de la presentación de los proyectos que tienen Quaker y Sigen, las y los quiero invitar a un coffee break, no más de media hora, por favor, afuera del aula magna, para que nos veamos de vuelta. Gracias por la puntualidad después del coffee break. Ahora vamos a dar paso al bloque de presentaciones de Quaker, en el que investigadores e investigadores de este centro van a presentar sus proyectos e investigaciones que están andando. Entonces quiero invitar, en primer lugar, a subir a Julia Becker, por favor.
Kia ora. I am Julia Becker, and I work at Massey University at the Joint Centre for Disaster Research. I'd like to also say that I am a social scientist, so I'm interested in the people side of disasters. So if you ask me any engineering questions, I might not be able to answer them. But as Liam was saying earlier, we have lots of disciplines working in the Quake Cool program, so social science is one of those disciplines. I'm going to talk a little bit about one of the specific research areas that we have in Quake Core on thriving residential communities. I co-lead this particular program with Tim Sullivan from the University of Canterbury. So just to briefly touch on what Liam was talking about a bit earlier about the Canterbury and Christchurch earthquakes in 2010 to 2011, this was one of the defining factors for starting up Quake Core. And what we saw during these earthquakes was that there was a lot of damage that occurred to residential housing. So over 10,000 houses demolished, and over 100,000 houses that were damaged. And so following these earthquakes, we realised that we needed to think a bit more about how to make our residential housing stronger, how we might need to build in better places, and how we can, I guess, move from this idea of the houses being safe for lives in an event through to them being livable after an event. So the life safety performance of the housing in these earthquakes, it was good. Nobody was generally killed if they were in a house, but the damage and the resilience performance of the houses were not good. And we saw that it was over a third of houses that were damaged in Christchurch that needed to be repaired, and we somehow need to improve that housing stock. So I'm going to talk to 3 areas of interest where we're doing some research, and these might be areas that you could be interested in learning more about and contributing to. The first is really thinking about how we make our residential houses more resilient and stronger in terms of future earthquakes. So one of the key questions might be, how can we retrofit some of our existing houses or build new ones so that there is less damage after an earthquake. And part of that comes back to understanding what some of the risks are to some of these houses. So are these houses located, or the ones that exist already, are the existing houses located in risky areas? And how vulnerable are these houses? And some of the engineering work that gets undertaken looks at trying to identify how houses might be vulnerable in New Zealand. And you can see a picture up there of some testing that's been done to see whether some of the plasterboard might crack in an earthquake. So there's lots of ways of trying to understand that vulnerability through looking at different engineering testing, I guess, and practices. So first of all, we need to understand our risk and our vulnerability, but also important are the land use choices. So where are we building our houses? Are they in good places? Unfortunately, in New Zealand, a lot of places already are in quite risky areas, so we have to manage that somehow through mitigation options. But if you're building new houses, can you put them in a safer place? And one of the examples you can see up there on the screen is quite an old development, quite close to where I live in Upper Hutt near Wellington. You can see there's a very well-defined fault running through the subdivision, and they've built the houses around the fault so that they're not directly over the fault when it might rupture. Unfortunately, New Zealand doesn't have great land use planning practices. It's very difficult to get some of these things done in efficient ways, so this is still a work in progress. And then finally, really looking at engineering and technical solutions to reduce damage and loss. So using the expertise from our engineers to understand how foundation systems might improve resilient housing, looking at low damage systems for some of the existing houses, and then when we're building new buildings, looking at resilient medium density housing solutions. And I know we had some discussions yesterday about maybe some of the differences between Chile and some of our residential houses, but there also may be some good lessons that we can share as well and learn from. The second key area of research is really around understanding infrastructure and how that relates to residential housing. So the key point here is that residents might choose to leave after an earthquake if their infrastructure is damaged. Their house might be okay, but if you don't have water, you don't have electricity, or some of these other services, you might need to leave your house. So how can we help people stay in their houses after a disaster? So understanding that relationship between infrastructure and housing is really important. And we recently had a large cyclone early last year, which highlighted some of those issues around loss of services such as water and power and people's ability to stay in their houses. So again, it's understanding what are the risks and the vulnerabilities in our infrastructure, and we did have some really good discussions again yesterday around some of the common problems that Chile and New Zealand has around infrastructure and some of those connections to infrastructure and the resilience of infrastructure. So that's really important work. But then also, how can we upgrade or build new infrastructure to be resilient so residents can stay after a disaster? And then some of the social science work that we do involves understanding what makes people go, or why do people need to go after a disaster? Is it a loss of water? Can people stay in their houses with no water? Can we deliver water to them? Is that enough? Or, do they have electricity? How long do they not have electricity for? Might this make them go? And where do they go? Do they go to friends, family, outside the region? So understanding some of those social science questions is really important. There's also people that choose to stay. For example, often after the Canterbury earthquakes, people chose to stay in places where they didn't have services because they had community around them. sense of community. So understanding why people might choose to stay, also important. And understanding a lot of these aspects can help us plan and prepare for these infrastructure outages better. How can we get people to stay, and what might we need to do if people have to move out as well. And then finally, the last research project that research focus, I suppose, that we work on is really looking at earthquakes, housing, and society in more general. So how do some of these individual, personal factors and societal factors, wider society, how do these interact when you're retrofitting perhaps old buildings or when you're trying to build new buildings? And I've got some examples up there of some of the things that we look at. Aspects like how much you perceive a risk or perceive a threat are really important. If you think that there's no risk, then you're less likely to prepare for a disaster or retrofit your house, for example. If you have a very high risk perception, you think it's going to be a terrible disaster, you might think, what's the point of preparing? It's going to be so bad anyway. So understanding how people think about these things is really important. People's experiences of previous events are important. If you've had an experience of an earthquake and it wasn't that bad, then maybe you're less likely to prepare because you might think the next earthquake might not be so bad either. So experiences can influence what people do. Catalina was talking about her project earlier, her PhD, understanding how people expect their buildings to perform. If you think your building is going to be fine in an earthquake, you might not do anything to prepare. If you think there's going to be some damage, you might decide to retrofit your house or make some improvements to your building. A really key point is people's beliefs about the benefits of mitigation. So if you think that by building a strong building or retrofitting your building, that it's going to perform better in an earthquake and you're going to have a better outcome, then you're going to be more likely to prepare or put together some mitigation options. So you have to understand what the benefits are. All of this can feed into the type of information we give people and how we communicate some of these things. One of the projects that Catalina was working on, for example, was a project looking at builders. We know in New Zealand that a lot of people get information from builders when they're fixing their houses or when they're renovating their houses. And so that's a really key information source. So builders might be one way of communicating that information out to residents in terms of making their houses stronger. And there are other aspects as well, so how much you participate or are empowered to work or act on these things. Economics, insurance considerations, also important. And whether you have the resources to do these things. Do you have money to be able to build a better building, build a stronger building, retrofit your building? And there are probably more that I could talk about, but these are, I guess, some key aspects that we look at in terms of some of these projects. I think that's probably it from me. Oh, that's my two little points on there. Too low, too high. But what we've got now is we've got some videos from students who have come to New Zealand. And so between each of the speakers, we'll play the videos of those students, and hopefully this will work out all good. So.
Hola, soy Eduardo Allen, alumno de doctorado de la Universidad de Auckland, el Departamento de Ingeniería Civil. Hice mi pregrado en la Universidad Católica en Chile, luego trabajé un tiempo en Sigiden, y creo que una de las principales motivaciones que me trajo a Nueva Zelanda es este desafío común que tenemos con Chile de los eventos de origen natural. Creo que Nueva Zelanda y Chile tienen un nicho de colaboración enorme en este ambiente. Actualmente me encuentro trabajando en resiliencia de redes de transporte e invito a todos los estudiantes chilenos a pensar en Nueva Zelanda como como un posible destino para sus estudios de posgrado.
If you had trouble hearing it, I'm sure we can play them for you again later if you want to check out what some of the students' experiences were a bit later on. But I'll pass over to Charlotte Brown now, who's going to talk about a slightly different project.
Thanks, Julia. Oh. Kia ora koutou, ko Charlotte Brown toko ingoa. Hello, my name is Charlotte Brown. I am from an organisation called Resilient Organisations. So we are one of the private research organisations that is a partner to Quake Corps. And I am also, well, I'm sort of an engineer and sort of a social scientist. I sit in the middle. I trained as a civil engineer, but now I would call myself a social scientist. So I'm involved in one of the interdisciplinary programs in Quake Corps, the transportation program, along with Liam, who you've already heard from today. So I just wanted to give an overview of some of the projects that are involved in this transportation system work. So it has already been discussed, there's lots of similarities between New Zealand and Chile in terms of the way, in particular our road system is. We are a long, skinny country with some difficult terrain or geography, so we don't have a lot of redundancy, or we don't have a lot of alternative routes going up and down our country. We also have a big coastline, but we don't really use that coastline in particular to move people or goods. We have a gap between the North Island and the South Island, and so that requires us to have ferry or boat access that moves both people and goods between the islands. If you remember back to some of the slides showing the fault lines that are in New Zealand, a lot of the fault lines are concentrated around that critical gap. So that is a potential risk for us, which I'll talk about in a little bit. We also fly a lot in New Zealand, but that's mainly just moving people around to get over that bit of water that is very annoying. So understanding the transportation system requires us to understand all parts of it. We do a lot of work on the vulnerability of the different aspects of the roading system, so bridge systems, but what we're also starting to do is look at transportation hubs as well. So when we're thinking about the resilience of our freight or logistics systems, it's important for us to understand not just how they get from A to B, but how the goods transfer between different modes of transport, so between road, rail, and boat. So a key piece of work at the moment is looking at the vulnerability of our hub systems, so that could be our ports along the coast, it could also be inland ports or logistics hubs where those goods are stored and transferred. So we're looking at the components, how vulnerable they are. We're also looking at that system of how things are transferred and how it connects into that wider system. As I said before, we're really heavily dependent on road transport. So if we're going to build our resilience, we need to understand how we're transferring between these different modes to understand the opportunities that we have to build resilience through using other systems. We've also had some real life learning in terms of disruption to that key asset that we have, or that key link we have between the two islands. We had the Kaikoura earthquake in 2016, which led to disruption at the port facility in Wellington. So we were able to learn a bit. Fortunately, it wasn't a huge disruption there, but we're able to learn a little bit more about how to improve that resilience. Still with the port theme and building on one of the slides that Liam showed earlier, we do have a significant tsunami risk, both from near shore subduction zone earthquakes, but also from far sources like Chile. So here, for example, we've looked at the potential impacts of a Chilean source earthquake on the different ports around our country and looking at the different wave heights. So this is trying to trying to help us understand how our port system and our overall freight network would be disrupted given one of these earthquakes. We have a very privatised port system, and ports are very competitive. They don't like to share facilities, but as you can see, if we've got damage across multiple facilities, there's going to be a lot of need for collaboration. So this is creating some of the evidence that we can use to talk to ports and our transportation system, logistics systems in general, to try and understand how we can make the system resilient, not just looking at individual assets or facilities, but the system, how it works as a whole to support New Zealand. So we've also developed some road models to show how, to help us understand both the vulnerabilities of our road network, but also the opportunities for improving that and building resilience. So through these models, we can look at things like exposure. Landslide risk is one of the biggest risks we have from seismic activity. So understanding which roads might be unavailable after an event, and for how long they might be unavailable. We're going to have a talk from Tom Robinson a little bit later on looking at the Alpine Fault, which is one of the large faults running down our South Island, and there's going to be some significant disruptions on the west coast there. So we want to understand what that means for both the people that are on the west coast but the rest of the South Island. We can also look at things like resilience metrics across our system. So both looking at the vulnerability of the components or the aspects, little different parts of the network, but also the system as a whole, and again, what that means for the people using the system. Again, we had an opportunity to calibrate our models after a recent event. So this is the 2016 Kaikoura earthquake, which Liam mentioned earlier. We lost one of the critical networks that runs up the east side of our South Island for over a year, which meant some really lengthy detours going inland. And we also had to ask the question, do we rebuild in that location, or do we need to move away from that risky coastline which could be affected by future events? We have another stream of work which really focuses on the freight system. So how resilient is our logistics systems, and how is it going to perform in a post-event response and recovery? And we're wanting to look at this really holistically. So not just about the assets and how they might be damaged, but how the assets work together, how the organisations that manage the systems, the freight companies that use those roads and those assets, how they are working, how we transfer information between different players, and how we operate and make decisions. And again, we want to make sure this is multimodal. New Zealand, I don't know if it's the same in Chile, but we have an obsession with cars and roads. We're always wanting to build roads, but we're trying to look really holistically about the whole system and how we can build resilience. So road, rail, air, and sea. So one of the projects we're looking at is post-disaster freight disruptions. So what are going to be the causes of freight disruption, and how able are we to shift and adapt to disruptions to make sure that the goods get through to the people who need them? We're also looking at logistics behaviours, so looking at past data from past events and understanding how logistics companies made decisions to decide how they were going to reroute their freight and how they were going to deliver their services, or what it was that they couldn't deliver. We've got a little bit of work looking at pre-positioning of relief items. So we've got a lot of, because of the nature of our roads network, we're going to have a lot of communities that are potentially isolated after an event. So should we be storing relief items? What is the benefit cost of doing so? I know you won't be able to read the details of that, but this is just an example of one of the projects looking at what happens to the freight system after one of our recent events, so Cyclone Gabrielle, as Julia mentioned. It looks at, there was a big impact on the delivery of fresh produce after this event. There was a lot of wastage of fresh goods that couldn't get to where they needed to go. A lot of things didn't arrive on time, or they went to the wrong place, and there was a lot of cost in the operation. So this was done based on a set of interviews where we looked at the root causes of why it was that these impacts occurred. And one of the key things that it highlighted, as I mentioned before, was that absence of using coastal shipping as an option to move goods around. So it's another thing that's just highlighting our need to look more widely than we currently do. Okay, the last program of work I wanted to mention was our Resilience Investment Decision Making Under Uncertainty. So this is looking at how we can effectively make decisions now that are going to place us in a really good position in the next 20, 30, 50, 100 years. And there's a couple of aspects that we're looking at here. One of them is the transport as a service expectations. So it's really trying to understand what people need from our transportation system. Is it to be connected to their loved ones? Is it to be able to receive food? Is it to be able to go to school? Is it just a sense of freedom to be able to move about? We really want to understand what it is so that then we can feed that into our prioritisation systems to make sure we're not just making decisions based on how vulnerable our current assets are, but to really critically think about what it is we need, and then therefore how can we design the system to meet those needs. We're also looking at how we can make transportation systems under those uncertain conditions. So how can we consider the future, and how can we understand how we can best prioritise those investments through time. So what do we need to do now, but what can we leave until the future? So one of the key tools that we have in New Zealand to help us make these decisions around infrastructure investment, not just transportation infrastructure, but across all infrastructure, is MERIT. MERIT is an economic impact assessment tool which takes damage to infrastructure and translate it into what it means for the community. So we start with asset damage, which is built through a loss modelling process. We have a couple of tools in New Zealand that do this, but that's for those who are familiar with the field, it's where you overlay hazard information onto the assets that you have in your community. And through the use of something called fragility curves, you can estimate the level of damage that you'll have across your assets. So that tells us, at the time of the event, what is damaged. What we then do is translate that into what that means for how long we might be without service for. How long will we not have water, electricity, who and for how long might be isolated. We also, while we're doing that, we consider the interdependencies between different infrastructure networks. So if we don't have electricity, that might mean, therefore, we don't have water facilities or wastewater facilities. What we do then is we look at what that means for businesses. How are businesses able to produce their goods given that level of loss of service and the duration of the loss of service? So we built this data based on evidence from the Canterbury earthquake, and we're always trying to update it and improve it to make sure it represents our best estimates of how businesses can operate under disruption. Alongside this, we also look at whether businesses might choose to relocate because it's just too hard to do business in a region. Or are people going to relocate, and are you going to lose staff through that process? There's a couple of other things we can include as well, like tourism, impacts on tourism, which is one of our biggest export commodities in New Zealand. This all gets fed into the engine of MERIT, which is the dynamic economic model, which is based on a computable general equilibrium model, but it's built in a system dynamics framework. So those are a lot of technical terms, but effectively what it means is that we can understand disruption through time. And it means that we can understand if the economy is going to change. So it allows us to report things dynamically. So we can see as the days after the event change, we can see which industries are being most affected. We can look at this at different regional scales, and a recent development is us to be able to look at different households, so we can understand which household types might be worst affected. So that's a very quick run through of the work that we're doing in the transportation space. We do a lot of this in other infrastructure as well. And I really am enthused about our visit to Sigidin and to Chile and the opportunity that we have to learn from each other and collaborate. So thank you very much for having us. Oh. Okay, so we're going to have another student presentation. There's a bit of background noise in this, so I hope the audio is okay.
Hola, muy buenas a todos y a todas. Mi nombre es Francisco Alves y soy exalumno de la Universidad de Auckland, donde realicé mi estudios de doctorado en Ingeniería Civil, especializado en computación numérica de verificación histórica sometida a movimientos sísmicos. Decidí ir a Nueva Zelanda porque ofreció una buena oferta en estudios específicos de alta calidad en los cuales estaba yo interesado, y al mismo tiempo ofrecía una buena compensación económica en cuanto a las becas que iba a recibir. Y al final continué mi carrera profesional en el país, donde trabajo en una empresa especializada en los estudios que realicé, y también me quedé por la calidad de vida que se vive con un ritmo tranquilo y con las necesidades, todas mis necesidades cubiertas de una manera muy satisfactoria. Así que animo a cualquier estudiante que esté interesado en hacer estudios de posgrado y considerar Nueva Zelanda como una muy buena opción. Un saludo.
Apologies from that audio. Hopefully you captured some of it. I'll just pass over to my colleague, Tom Robinson now.
Kia ora koutou katoa, ko Tom Tokuingoa. So that is the Maori way of saying hello, welcome everyone. My name is Tom. Apologies to our translators for adding a third language to your workload. So I'm going to talk today about some of the work we're doing focused on one very specific hazard that faces us in New Zealand. And in particular, I'm going to walk you through some of the steps that we've been doing to try to understand the hazards that one of our big earthquake threats would cause in New Zealand, the potential losses that we might experience from that, but also open up and identify some of the avenues where we've got ongoing research to try and better understand and better quantify some of these major hazards. I appreciate we're also supposed to be advertising New Zealand in this in these talks, and perhaps looking in detail at one of our major earthquakes might not do that, but the idea is to show you the avenues of research we have to really delve into some of this stuff. So we've seen this slide from Liam before, looking at the Pacific Ring of Fire, where New Zealand and Chile share. What I'm going to do here is I'm going to focus in on one very particular part, on one very particular fault within Aotearoa, New Zealand, which is the Alpine Fault here, which is the onshore portion of the plate boundary. This is a really interesting fault. It's one of only two locations where the Pacific plate boundary comes on shore, the other being probably the most famous of all, the San Andreas. I'm also focusing on the Alpine Fault because our subduction zones are quite scary, and so we'll deal with the slightly less scary faults to start with. But this is an extremely long fault. It runs from the very southern tip of the South Island there, right through the west coast of New Zealand for about 450 kilometres. So those of us in New Zealand that live on the west side of this fault, they're actually really Australians living on the Australian plate. The real New Zealanders live in Canterbury on the other side of the fault, which I'm sure many of my Auckland colleagues will not appreciate me saying that. But this is a particularly worrying fault for us in New Zealand, and one that we really have put a lot of focus into. And the reason for that is it's one of the best studied faults in the world. This is, while the San Andreas is probably more famous, we actually have a lot more data on this fault than anywhere else in the world. And so what you can see here, this is a rather complex graph, but what it's showing you is moving from left to right, we're moving through time, going back about 8,000 years. And as you move vertically up that graph, we're moving through previous earthquakes on the Alpine Fault, and all of these little squiggles are showing you when previous earthquakes have occurred and how confident we are. And what we've been able to work out from this is that over the last 8,000 years, there have been 27 earthquakes on this fault. The more worrying thing about this fault, though, is that those earthquakes have not come randomly through time. They've come at very defined time periods. And they happen very frequently and over the same length of time. So looking at that graph, we can see that each earthquake, on average, has about 300 years between one earthquake and the next earthquake, which begs a really important question about when was the last earthquake. And we know categorically that the last earthquake was in and around 1717. If anyone here is particularly good at mental arithmetic, 1717 plus 300 takes us to 2017. So we're well overdue for this large earthquake. This event is inevitable, and the latest research that we've got from this suggests that there's a 75% chance that this will rupture in the next 50 years. Looking around the room, I'm assuming everybody in here is anticipating living another 50 years. So there's a really strong chance that we will all experience an Alpine Fault earthquake at some time in our life. Importantly, this fault is long, and it's capable of very large earthquakes as well. And we think that this fault could generate a magnitude 8 earthquake. And so there's been a huge amount of research that's gone into what that earthquake would actually look like. And so this video here, or this animation, is showing you what we consider to be one of the worst case scenarios of an Alpine Fault. So this is a rupture that starts down at the southern tip of Aotearoa, New Zealand, and ruptures northwards towards our heavily populated areas at the top of the South Island and the bottom of the North Island, and particularly Wellington. And so what you can see here is the waves spreading out as they move up the island. The more that the topography there is jumping up and down is showing you the strength of the shaking, obviously somewhat exaggerated for effect. And we can see a lot of different things here. So we can see, firstly, how long this earthquake takes. So if you look at the top there, you'll see that we're nearly 2 minutes into the earthquake now. But you can also see the strength of shaking and how long waves take to pass through different parts of the country. So here at the bottom of the image, you can see those waves entering what's known as the Canterbury Basin, the flatland of New Zealand, where I just so happen to choose to live in Christchurch. And you can see how long the shaking there might last. Christchurch is a wonderful place to visit. Please don't take this as a reason not to come to New Zealand. But we can see that in parts of Christchurch, for instance, that shaking could last for a minute or more, which is a really significant period of shaking. But one of the things that we understand very well in New Zealand, but that we want to understand more, is that the shaking is just the start. That earthquake might last for 3, 4, 5 minutes, but that is just the start of a cascade of secondary hazards that are going to spread out across the island and cause widespread impacts. And so we're really interested in understanding how that shaking triggers these hazards and causes impact to our people, but also our critical facilities, and particularly our critical infrastructure. And so a good example of a very basic chain of secondary hazards might be we have strong shaking, and while shaking buildings and damaging buildings, that also shakes mountains and damages mountains and triggers landslides. Those landslides fall to the bottom of the mountains where we have rivers, often very narrow rivers with not much room. And so that may block the river and stop the water flowing, forming what's known as a quake lake or a landslide dam. And that dam is uncontrolled, so the water fills up, and slowly but surely it reaches the top of the dam and it overflows. And that weakens the dam and eventually causes that dam to fail and cause a dam break flood or an inland tsunami. So while in Chile we might be interested in tsunamis that come from the sea, in New Zealand one of the things that we're particularly interested in is tsunamis that come from the mountain in the directions that we're not perhaps as expecting. And then we have to add on top of that we'll be having constant aftershocks, we may get fire, and New Zealand is in the bottom of the South Pacific, it's very exposed to weather, and so we will probably have large storms coming through in the intervening period. What does this mean for our landscape and our assets as they're exposed to it? Whoops. So liquefaction is one of those key hazards that we're particularly interested in, and there's a lot of research going on. It's particularly a threat in some of our reclaimed land and in our marshlands, which just happens to be where most New Zealanders choose to live. And so we're particularly exposed to liquefaction. You can see here pictures of port damage from the 2016 Kaikoura earthquake. And then the map on the right-hand side is showing you our road networks, our critical transport networks, and how susceptible they are to liquefaction. And you can see here that in a major event, many of our highways, particularly in the South Island, would be expected to be damaged. And so one of the key questions we want to ask here is, what does that mean in terms of serviceability? Are we able to still travel along these roads, or is the damage going to be so great that they're completely blocked and impassable? And so that's a key question that we have, is how does this translate into that loss of service? Arguably one of the greatest hazards, and one of the ones that I focus most on, is landslides. We have very large mountains in the South Island, perhaps not as large as the Andes, but we think of them as being fairly impressive. And what we can see is that if we shake buildings, those buildings get damaged, but if we shake the topography is damaged extensively as well. And so the image, or the map there on the right, is showing you in cool colors where we would not expect landslides, and then as we move into those orange and red colors, really where we would expect intense landsliding. And you can see some examples of images there. We've recently had an experience of a major landsliding event in the North Island.
We think there is probably many landslides triggered by sudden vapor. Our previous estimate to this extent might trigger today's about, we were starting to revise as and started to look at us. It adds a lot to the show, our shots and it was as we thought I really was, and isolate means it's and take there.
On the other side of the fault. But we also have a new hazard that the Kaikoura earthquake in 2016 showed us that perhaps we hadn't really anticipated before. And this is where faults cross rivers. And when we have faults that cross rivers, they can shift the river's channel and actually change the way the river flows. So if this works, yeah. So what you can see here is a river that has been displaced by the fault. The river should flow on the top end of that image along the mountains, but the fault has completely displaced that and caused the river to instantaneously change course and flow across a completely different part of the landscape. This happens to be quite a lot of productive farmland in this part of New Zealand that's only connected by one road in and out. And so you can see this water pooling up, it builds up at the fault, and then eventually it bursts back through and re-engages with the main channel. And so this is a hazard that we've recently been introduced to, and one that we're trying to better understand, particularly in some of our more urban areas like Wellington, where we have a fault crossing a river right through our urban areas. And so does this mean that after an earthquake, we could expect widespread flooding through some of those communities? So that is a whistle stop, or a very quick tour through the multiple hazards that we experience, or we think we'll experience in New Zealand. And we're just touching the surface of many of these. And so there's really a lot of work streams trying to better understand each of these individual hazards and how they connect. And in particular, this coincides with the program we have, for which I'm the science lead, which is AF8, Alpine Fault Magnitude 8. You can see the information there. I mean, it's just this slide is just to point out that this is a widespread collaboration of which Quake Corps funds and is part of, but really working with our emergency management, our civil defence groups to better plan and prepare for these events when they occur. So get the science directly from the scientists into the practitioners that need it in the aftermath. So I will stop there. I think we have another student coming up. Yes, Rosa. Hopefully the audio is much better.
Hola, soy Rosa González, soy ecuatoriana. He estado haciendo mi doctorado aquí en la Universidad de Auckland en los últimos 4 años. Mis supervisores son Charlotte y Max. Trabajar con ellos ha sido una muy buena experiencia a nivel bastante técnico, son bastante buenos y realmente también se han preocupado bastante de mi bienestar. También en Nueva Zelanda he tenido oportunidad de presentar en conferencias nacionales y el nivel técnico de aquí es bastante bueno. Además pienso que es un país muy bueno para vivir respecto a seguridad y en ambiente en general. Y bueno, mi investigación se trató de impactos ambientales respecto a los impactos sísmicos o después de un evento sísmico.
Gracias. I hope you could hear that. Now I'll hand over to my colleagues Max Stevens and Charlotte Thoma.
Kia ora. My name is Charlotte Thomas, my colleague Max Stevens, and we're going to talk today about sustainable structures and multi-hazard response. We managed to get the wrong head of the coin toss and have ended up with the very last lot and being told to very much hurry it along. But having said that, I have some very key information for you. Just to let you all know, New Zealand does not have any snakes or any poisonous spiders. So please keep that in mind when considering your options. Oh, it does jump. Okay, sorry, it's a jumping slide. All right, so we've been talking about hazard, but we're going to talk to you about something slightly different, and that is the very real and very current challenge that we have in terms of climate change. So we as engineers do have a part to play in reducing our emissions. The built environment globally contributes around 30% of emissions. And if we were to break this down a little bit over what that looks like, we can separate these into embodied emissions and operational carbon. Now we're talking more around the embodied carbon, which is the emissions associated with the materials that we use to build our buildings. And we look at this across their entire life cycle. The other important point to make here is that similar in both New Zealand and Chile, is that we're not responsible just for the emissions associated with the products that we produce locally, but we do need to look at this from a consumptive approach, which means accounting for all the materials that we import. And for both New Zealand and Chile, that's actually much higher than the materials and the emissions that we use. So if we were to look at that emissions profile across a typical building lifespan and how we think about life cycle analysis, we can see that there's a large portion of these emissions that are associated in that early phase of the building, right up front when we're first building the structure. We don't have a lot of emissions through the life cycle or through the lifespan. The building generally just sits there. There might be a little bit of maintenance and a little bit of uptake. And then we have another block of emissions associated with the end of life of that structure. Now that's all well and good, except we have heard over and over today that our buildings are likely to see hazards, whether that is earthquakes, tsunamis, even wind events related to climate change. So if we were to take that into account, oh my goodness, this is very sensitive, we might see a spike, essentially, in emissions associated with the damage that could occur to our structures. So we've identified this, and we're kind of discussing this concept as seismic carbon risk. So if our building were to see some type of earthquake event, then we might have some repair strategy to save that building, but in a significant earthquake, we are likely to see buildings being demolished and therefore rebuilt. Right, you go.
So Charlotte and I have spent the last 4 years with our PhD student Rosa Gonzalez, who you just saw speak, trying to establish links between structural resilience and sustainability. Because some people argue that you can either have one or the other, but not both. I'm not going to show any of the results here in the interest of time, but during our time doing that research, we've encountered a number of complexities, and so I've listed some of those here. One is, how should we actually be predicting loss? So a lot of the methods that we use to estimate loss from earthquakes tend to downplay things across the life cycle of a structure, accounting for how unlikely it is that the structure will experience an earthquake during its life. The next is, what will be the carbon intensity of our future buildings? So if the carbon intensity of our materials decreases, do we actually care if the building gets damaged in an earthquake and we can rebuild it with limited environmental impacts? The next is, what is the actual life of our buildings? You know, as structural engineers, we say this building has a 50-year design life. I'm pretty sure the building we're standing in right now has been around for more than 50 years, right? So that's something that's really important to consider when looking at life impacts across a building life. The next is, when should we strengthen and reuse a building versus demolishing and rebuild it? And this is actually a point where I think New Zealand is slightly different than Chile, in that we've designed our buildings to be very flexible and experience damage during earthquakes rather than strong and stiff that can be reoccupied immediately following an earthquake. So for us, it's very important to have tools to make decisions about strengthening buildings or retrofitting buildings to make them stronger to resist future events. And then finally, what does carbon risk look like across different building forms? And we need to make sure that we're building buildings that both meet our resilience and sustainability needs, but we can also use, because in the end, we are the ones using these structures. So we have a few projects that are starting up. The first is called the carbon curve of seismic strengthening. As I just said in that last bullet point, what we want to do here is use carbon as a driver towards informing demolition decisions or decisions to retrofit and reuse structures. So how can we use sustainability as part of a driver towards future building use? The next is called robust structural design for housing. Here, we're trying to look at what the next generation of housing looks like, and that could be either in New Zealand or Chile, but essentially, again, we want to make sure that we are building houses that we are comfortable living in that meet our carbon and resilience needs. And then this whole thing was set up based on sustainability, but Charlotte and I are also working in the space of tsunami, and specifically tsunami impacts on structures. And what we're really interested in is how existing structures respond to tsunami impacts. So in New Zealand, we currently don't design our structures for tsunami at all, only for seismic. So the first stage of this research has been looking at case study buildings that we've then tested in a small scale flume. So you can see some of our little experimental specimens here. And so we're going to have a lot of work coming forward in completing these experiments, performing some computational fluid dynamics, scaling all that up, and looking at how our existing building stock responds when subjected to tsunami attack. Cool. So that's it for us. Yeah, really excited to be here and talk to you.
Un aplauso nuevo para las presentaciones de la investigadora e investigadores de Quaker. Y bueno, antes de continuar, queremos agradecer la presencia de representantes del Servicio Aerofotogramétrico de Chile, del Ministerio de Vivienda y Urbanismo, de FOSIS y TREN, y para quienes nos están viendo también por el canal de YouTube de Sigiden. Y ahora, para seguir con el bloque de presentaciones, vamos con las investigadoras de Sigiden, Catherine Campos y Leila Hussam, quienes nos van a presentar el libro Ciencia con Impacto, aportes a la política pública en gestión del riesgo de desastre. Recordarles que por persona son 10 minutos, se pueden pasar a lo más 2-3 minutos. Gracias. Ya. Sí.
Hola, buenos días. Muchas gracias por la organización del seminario. Bueno, yo soy Catherine Campos, soy editora ejecutiva de la serie Policy Papers y trabajo junto a Leila Hussam, que se va a sumar en unos minutos, espero, estaba acá, quien es editora general también de la serie Policy Papers. Y lo que vamos a presentarles a continuación es, bueno, en parte el libro Ciencia con Impacto, aportes a la política pública en gestión del riesgo de desastre, pero también queremos compartir con ustedes parte de la experiencia que hemos tenido en Sigiden con la serie Policy Papers y que de alguna manera se materializa o se cristaliza, ¿cierto?, en este libro que lanzamos recientemente el 19 de marzo. Entonces ahora a continuación les voy a dejar con Leila, quien va a presentar parte del trabajo que hemos realizado en la serie Policy Papers y luego ya vamos a presentarles parte del libro.
Hola, buenas tardes. Bueno, como les dijo Catherine, vamos a presentar sobre la serie Policy Papers. ¿Se escucha bien? Ya. Y que finalmente uno de los productos de esta serie es este libro, del que después les va a comentar Catherine. Pero primero vamos a contar un poco cómo surge esta serie. Perdón, es que soy un poco chica, entonces... Bueno, SIGIDEN tiene una trayectoria de más de 10 años en la cual se ha trabajado arduamente en la elaboración de artículos científicos, publicaciones diversas, informes, reportes, participación en congresos, seminarios, actividades académicas, plataformas, entre otras. Y en algún momento en el centro nos cuestionamos si es que esta información estaba llegando a los tomadores de decisiones, por ejemplo, si es que la información que se estaba generando valga la redundancia, un impacto concreto, y se pensó que una herramienta para que esto ocurriera podrían ser documentos orientados hacia la política pública. Entonces, nos hicimos la pregunta, ¿qué es lo que necesitamos para que la investigación que se realiza en el centro tenga un impacto? Como decía, se pensó que una buena forma era la elaboración de documentos, a los que les llamamos policy papers, direccionados a ciertos ámbitos vinculados con la gestión y reducción del riesgo de desastre. La idea era contribuir con ideas, propuestas generadas y que surgieron y nacieron en el centro a partir de la investigación científica y obviamente direccionada o en el marco de la gestión del riesgo de desastre. Y entonces, en 2019 se crea formalmente la serie cuando se publica el primer policy paper llamado Evacuación Vertical como medida de mitigación del riesgo de tsunami en Chile. Viendo las presentaciones previas de Quakecore, creo que hay una línea que está muy vinculada a lo que estamos haciendo desde la serie de Policy Papers. El trabajo que están haciendo ustedes en Quakecore, que apunta a los mismos objetivos de tener incidencia en política pública, es algo bastante interesante y que pienso que podríamos explorar. Tal vez luego de que termine este seminario, y también contarles un poco por qué, o sea, respondiendo un poco una pregunta que se nos ha hecho en varias ocasiones, de por qué le llamamos policy papers. Contarles que, bueno, SIGIDEN es un centro que está financiado por ANIT, es un centro de excelencia que tiene que hacer los informes en inglés. Eso es por un lado. Entonces, además de que la producción académica en general está muy abocada hacia la escritura en inglés, pensamos que era un buen nombre, pero además nos hemos dado cuenta que a pesar de que han surgido ciertas inquietudes o preguntas desde el público aquí en Chile de por qué le llamamos policy papers, nos hemos dado cuenta que con este nombre hemos llegado a muchos lados, no solamente a impactar en la política pública aquí en Chile. La serie se ha hecho conocida también internacionalmente, así que nada, es como una de las razones también por las que mantenemos este nombre. Como ya les mencionaba, los policy papers tienen como objetivo traducir la investigación que se realiza en SIGIDEN en documentos cortos, direccionados estratégicamente a la política pública. Y respondiendo, perdón, el micrófono, respondiendo a las inquietudes de algunas personas de Sijidén o de afuera, les vamos a contar un poco cómo es el proceso de elaboración. Primero que nada, decir que esto es este trabajo se realiza a partir de la intención voluntaria de investigadores e investigadoras de Sijidén en participar. Estos no son publicaciones académicas, por lo tanto no cuentan en nuestros registros como, o sea, no tienen ese incentivo que muchas veces tiene la academia. Entonces este es un trabajo que se hace gracias a las voluntades personales de investigadores e investigadoras. Es un trabajo que tiene cierta complejidad en el sentido de que muchas veces para investigadores e investigadoras es difícil poder traducir el lenguaje técnico, bueno, o desde las ciencias sociales a veces como medio rimbombante o pomposo, es algo que ya había mencionado antes, pero para no solamente criticar, entre comillas, a quienes vienen de las ciencias más duras y técnicas. En general es un trabajo que puede ser desafiante, pero creo que es muy abordable. Más adelante se los podrá comentar también Rodrigo Ramírez, que va a presentar su proyecto Gemil, y quien es una de las personas que es uno de los autores de uno de los policy papers, y que es posible realizarlo. Entonces es una invitación a quienes nos están escuchando que son parte del centro, pero que también puede que sean parte de otras instituciones que quisieran colaborar, porque hemos hecho trabajos con otras entidades en colaboración. Bueno, muy rápidamente lo que significa un policy paper es esto: hacer un documento que tenga lenguaje claro, sencillo, conciso, con un título llamativo. Para eso estamos también Catherine y yo, que somos las editoras, para colaborar en todo este proceso. O sea, no es un trabajo que hagan solos y solas las investigadoras e investigadores. La estructura, muy rápido, es un resumen ejecutivo, una introducción, un prólogo que no aparece acá, que en general buscamos que sea alguien o del mundo público o de la academia que tenga una posición importante en el tema que se está abordando. Contexto, desafío regulatorio, que es lo principal, y las recomendaciones y conclusiones que son también el foco de estos documentos, porque lo que buscamos es que tengan un impacto en la política pública, ya sean leyes, normativas, etcétera. Aquí hay una lista de los documentos que tenemos hasta la fecha, son 16. Dentro del libro que va a presentar ahora Catherine y que se está vendiendo allá afuera, por si acaso, editado por Ediciones UC, tenemos 15 de los 16 documentos publicados a la fecha. El último, que fue sobre incendios, no pudo ser incluido porque salió en diciembre. Pero estamos abiertos a seguir trabajando, seguir impulsando la serie y obviamente a seguir haciendo vinculaciones y alianzas con otras entidades, otros centros de investigación y, ¿por qué no, Quakecor? Los dejo entonces con Catherine.
Bueno, recién estuvimos revisando, ¿cierto?, de qué se trata la serie de Policy Papers y cómo llegamos finalmente a construir este tipo de documentos. Y ahora les voy a presentar brevemente, como les decía anteriormente, como el producto que de alguna manera cristaliza esta experiencia que hemos llevado a cabo en el centro. y en el que presentamos 15 de los documentos que hemos producido a la fecha. Lo importante a destacar acá es que los documentos que hemos producido son documentos que vienen o parten, ¿cierto?, de experiencias multidisciplinarias y también experiencias participativas que hemos tenido en el centro, ¿ya? Por otro lado, si bien este libro, y como también lo voy a mostrar más adelante, gran parte de estos documentos partieron siendo escritos en el año 2019, de ahí en adelante hemos tenido una publicación de aproximadamente 6 documentos por año, ¿ya? Estos documentos fueron escritos en su mayoría antes de la promulgación de la ley 21.364, que es la ley que finalmente vino a modernizar el sistema público de respuesta y gestión del riesgo de desastre en Chile, ya que es con el que se crea lo que hoy día antes era ONEMI y que hoy día es llamado SENAPRED, ¿ya? Pero a pesar de que gran parte de estos documentos se crean antes de la promulgación de esa ley o mientras se estaba desarrollando esa ley, la verdad es que los documentos logran recoger varios elementos que hoy día son contingentes y que se alinean con lo que se ha abordado a nivel internacional también en materia de gestión del riesgo de desastre. Por lo tanto, también recoge varios desafíos y varios elementos que están contenidos hoy día en el marco Sendai y en la Agenda 2015-2030. Otro elemento importante a destacar de este libro es que finalmente las experiencias y lo que recogemos en cada uno de los policy papers están basados en las experiencias y en los aprendizajes que las y los investigadores de SIGIDEN han ido construyendo a lo largo del tiempo. Algunos tienen que ver con investigaciones finalizadas, otros con investigaciones en proceso, ¿ya? Pero vamos construyendo en conjunto, junto con Leila, junto conmigo, con el equipo Policy Papers, ¿cierto?, cómo esas investigaciones pueden tener un impacto en materia de política pública y cuál es esta contraparte en el sistema público al que queremos hacerle recomendaciones o al que queremos de alguna manera contribuir en el quehacer, en su quehacer. Entonces, el libro se distribuye en 4 grandes capítulos, ya voy a nombrarlos rápidamente. El primer capítulo es Desafíos de la gestión de la costa para la reducción del riesgo de desastre, que agrupa ahí 3 documentos que están relacionados con la gestión de la costa y el tema de la gestión del riesgo de desastre. El capítulo 2 es el capítulo que se titula Herramientas para la reducción del riesgo de desastre, y acá podemos encontrar documentos que van en la línea de la planificación urbana, de los mapeos colectivos, pero también otros documentos como, por ejemplo, los sistemas de monitoreo y alerta temprana y el tema de la evacuación vertical. El tercer capítulo, que es el que iba a mostrar más adelante, el tercer capítulo se titula Integrando a las comunidades en la gestión del riesgo de desastre, y ahí recogemos 3 documentos que justamente abordan el tema de la participación ciudadana, por un lado, en las políticas de gestión del riesgo, también cómo incluir a las comunidades en los procesos de reconstrucción, y por último, diseñar la información de emergencias, que es parte de la experiencia que Rodrigo va a presentar también en unos minutos más. Y el cuarto capítulo y final se titula Impactos diferenciados de los desastres, la importancia de un enfoque interseccional. Y acá tenemos diferentes documentos que, por un lado, abordan el tema de la perspectiva de género interseccional en desastres, pero por otro lado también aborda, por ejemplo, el tema de la vinculación, ¿cierto?, en el trabajo de las mujeres indígenas y la acción climática, el modelo de gestión del riesgo de desastres en campamentos, que son, así llamamos a los asentamientos informales acá en Chile, y el tema de los requisitos informacionales para la comprensión del riesgo de desastres, que ahí tuvimos una colaboración muy interesante con colegas que vienen de la economía y que presentan algunas propuestas de cómo se podría evaluar finalmente el impacto económico de los desastres. Como les decía anteriormente, lo que buscamos hacer con este libro es finalmente poder contribuir, ¿cierto?, con elementos, con herramientas, también con algunas propuestas quizás que a veces pueden ser teóricas, pero que buscamos de alguna u otra forma de hacer más digeribles ya para que el público general también pueda adentrarse en el tema de los desastres. Y bueno, y en su conjunto, la verdad es que a quién va dirigido este libro y a quién va dirigido estos documentos, si bien lo pensamos en un primer momento como documentos dirigidos a tomadores de decisiones y a público experto, también pensamos que puede ir dirigido a público que esté interesado en la temática, pero que no necesariamente es experto ya en todos los ámbitos, porque acá tenemos escritos que vienen desde la ingeniería, desde la geografía, desde la economía, la sociología. Por lo tanto, también la forma en la que están estructurados, bueno, en este caso los capítulos y también están estructurados cada uno de los documentos, busca ir interiorizando a ese público en esos temas o en esos conceptos que son propios, ¿cierto?, de la temática que se aborda en cada uno de los policy papers. Y bueno, y cómo seguimos, contarles un poco también que el trabajo que se ha realizado en la serie Policy Papers, como decía Leila, si bien fue pensado en un primer momento más dirigido al contexto nacional, también nos hemos encontrado con que se han ido utilizando parte de los elementos que hemos propuesto como inspiración ya para también en otros lugares, en otros países de Latinoamérica. Entonces, también pensando en que ya hemos ido consolidando la serie Policy Papers, hoy día tenemos un producto que es el libro, que se está vendiendo también a la salida del salón. Nos preguntábamos en Sigiden, bueno, cómo avanzamos también un poquito más allá de la producción de documentos a efectivamente la incidencia, cómo finalmente esto impacta, ¿cierto?, el público. Y en esa línea es que hoy día hay un equipo de trabajo, el eje Risk, Governance and Public Policy, tiene un nombre en inglés, pero básicamente lo que buscamos es generar una estrategia organizada por parte del Centro de Investigación en la línea, ¿cierto?, de incidir con evidencia científica en la política pública. Y acá les dejamos algunos links, uno que es del libro, ya donde está a la venta, pero también de la serie Policy Papers. Si bien el libro hay que comprarlo, los documentos, cada documento, que es la serie Policy Papers, está disponible al público abierto para poder ser descargados los documentos en PDF desde la página web de Sigiden. Muchas gracias.
Muchas gracias a Catherine y Leila por su presentación y contarnos cómo la evidencia científica y multidisciplinaria que se desarrolla en Sigiden puede transformar y mejorar las políticas públicas de Chile en torno a la gestión del riesgo de desastre. Ahora quiero invitar a nuestra investigadora Orieta Nicolis. Ella es académica de la Escuela de Ingeniería de la Universidad Andrés Bello e investigadora de nuestro centro.
Thank you. Thank you for the invitation. I will try to speak in English so for a better understanding with the colleague of New Zealand. And I'll speak about the prediction of seismic event by combining statistical method and deep learning neural networks. I am a professor of the University Andrés Bello and a member of CICIDEN. And in this slide, I will speak about the earthquake prediction. And the question that always we say is, can earthquakes be predicted? Probably not. We cannot predict the main event, but we can try to predict the aftershock, the number of the aftershock, and to try to have a probability where the next event could happen. And so here, for example, another question is why it is important to predict earthquakes. Here we can see some pictures about the damage that can produce the earthquakes. The first picture is about the Concepcion earthquake, the second about Aquila in Italy, and the third the Haiti. And then we can see quite a line all the earthquakes that happens by the application of our cellular. And we can control that in every part of the world, every day it happens earthquakes with more or less magnitude. Why the study of the seismicity in Chile. My work is essentially about Chile because Chile is one of the most seismic country in the world. Here there are some statistics that, for example, this is all the work from 2007 to 2015. We had more than 150 earthquakes. Now we have more, with magnitude measured than 6 on the Richter scale and also on the moment scale. And then, on average, we have an earthquake with a magnitude measure of 8, then 8 every 10 years. This is caused the expression that we are situated in the ring of fire, as we can see in this picture. On the left, we can see some statistics. For example, the number of events in Chile every year. And we can see the most higher peak is about the 2010 earthquakes in Talcahuano, Concepcion, and the Maule earthquake. And the second picture on the left, we can see the earthquakes respect the magnitude. And so we can see that normally we have not knowledge about earthquakes with magnitude less than 2 or 1.8 grade of magnitude, because these are missing values because the instrument cannot detect the smaller one. Here we can see, for example, one of the publications, some picture of the publication that we can show that Chile is one of the most seismic country because it's closer to the Nazca Plate that go behalf the continental plate. And as we can see from the picture that the earthquakes can cluster in 2 points. One are the interplate earthquakes, where the plate meet, and the other one interplate earthquakes. So there are 2 kinds of earthquakes. One is in earthquakes with are and deeper. The second graph is about the frequency respect to the depth. And so we can see that the measure of earthquakes are between 40 and 60 kilometers of depth, and the other is about 120 and 120 that are close to the Cordillera. And why to predict with a probabilistic model? Because it's important to have a grade of uncertainty about the happening of the earthquakes. One of the processes that we use for predict earthquake is the Poisson process. But the Poisson process with clusters, so we say that this Poisson heterogeneous Poisson process in space. And the Poisson process are characterized by this formulation that indicate an average number of events in space, in this case only space, but we can extend also in time, where the points are random, but they tend to cluster. And so these are the main definition. But this process are characterized by the intensity function. And the intensity function is a sort of graph with different colors, where put like this, the red colors, where there is the major intensity of point, of spatial point. And so we can represent by this. The other law that we have to take into account in the prediction models are the Omori law that say that the number of earthquakes is a decreasing behavior with the time, as in the first graph. And obviously with a different exponent. And the second is the Gutenberg-Richter law that they say that there is a proportionality between the magnitude and the number of events. If, for example, in the logarithm scale is linear or quite linear, that we can see that for example, the number of small earthquakes with a smaller magnitude are major than the earthquake with a lower magnitude, according to this lay. And one of the most famous model is the ETAS model, that is the epidemic time aftershock sequence model. This model was derived by epidemiologic model because earthquakes tend to cluster in a similar way of epidemiologic data. And this model was introduced by Ogata in 1988 and Ogata 1998 for the extension to time and the spatio-temporal model. So we can estimate by these models the intensity function, that is the average number of earthquake in a given time and space. So we can estimate in space and time where will be the next earthquake. But they are introduced especially for estimate the triggering event. In fact, the function is composed by two elements. The first one that is me for Fs. This is an parametric function of a past event. And the second one that includes the Omori law and the Gutenberg-Richter is the triggering function, that after a principal earthquake, there are many earthquakes that follow in this way. And so after a first wave, the probability function that there is another one is larger. And this function is characterized by different coefficients that we estimate by likelihood function, like mi, k, c, p, that indicate all the propagation in time and space of the earthquakes, and the longitude of the earthquake cluster, especially. In the study of Chile earthquakes, we had a different finding. For example, we studied 3 parts of Chile: north, center, and south, and this function divides the earthquakes in 2 maps. One is for the background, that is where there is a seismicity, a basic seismicity, and the one is the triggering. And so this feature is the resulting of triggering more the background seismicity. And over there we can see the parameter that you can estimate for the prediction model. We also analyzed a different part of Chile, and we divided Chile in 30 windows. In these windows, we estimate all the parameters of the ETAS, and we found that there is a different parameter for each window. So it's not possible to use a unique model for all Chile, because also the movement of the plate is different from the north to south. For example, in the north, the movement is about 7 centimeters at year. In the south, it's about 4 centimeters per year. So we have a different model, and some extension of the ETAS models that produce this map, that are a map of background seismicity, a back of triggering seismicity, are different for different zones. Here in this paper we study different part of Chile, showing the different parameters. Then we developed a prediction model, and we predicted, for example, 120 events after the main shock. In particular, we started, for example, this is an example for the earthquake of 2014, for the Iquique in the north of Chile earthquake. And this earthquake was characterized by precursors, by foreshock. But the model didn't detect so much the foreshock, but detected especially the number of foreshock. And this kind of model are not so good for predictive event, but they can detect the area, as we can see below, and where the earthquakes happens after the main shock. For example, the red start indicate the earthquakes, and this picture, the first one, indicate 5 days after the main shock, and the second 20 days after. So the white color indicate the intensity function that is the number of average number of earthquakes that are predicted. Then we introduced other covariate, for example, in the model, for example, the GPS velocity and the GPS displacement. And this we found that the prediction of aftershock improved. At the end, we decided to communicate ETAS model with neural network with computational model to see if it is possible to do a better prediction. And since we had a lot of data, so in this work we started with the catalog, and we apply a neural network with memory, putting all the last memory, the historical earthquake as input, and for predicting the probability of the next event. And so we try to do a space-time model by joining these two models. In particular, this green is the intensity function estimated by ETAS model, and you put it as an input of a neural network. LSTM is a neural network that is appropriate, adequate for the time series, and the meaning is a long short time memory, because it can give different load to the past event according to the importance. And then we apply a convolutional neural networks for trying to understand the space where, in which zone will happen the earthquakes. Obviously, it was quite good, but it was not perfect, the prediction. Also, the error was not so good. So we decided to extend these neural networks with other input, for example, the GPS, crustal displacement with velocity displacement. And here we did a multi-column convolutional LSTM that is a very complex neural networks that go in parallel. One for the one input that was the intensity function, and one for the GPS displacement. In this way, we improve it a little bit, the prediction. But then we try to cluster event and use the cluster for input to a neural networks and predict if the next event could be a precursor, could be for a shock or main shock or aftershock. And so we predicted the label. But a lot of work has to be done. And from all this work, we try to do some conclusion, especially that the seismicity is different along the coast of Chile, and so different models had to be used for different part, and that the displacement velocity derived for GPS measurement are important for the prediction. And that cluster analysis can, where we can classify the event in for a shock, main shock, and aftershock, can be used also for predict the label of the next event. However, we are working on incorporating more geological and geology variable. For example, we are studying magnetism, cosmic rays, and solar cycle. And we try to put in the neural network some pattern that we can see from this time series. Then another important model is using explainable neural network, that is XI. This XI allows to see the relationship between the input of a neural network and the output, because the neural networks, they are considered black boxes. So we try to explain, to open the box, and to see what there is within. And at the end, we are also trying to introduce an uncertainty of prediction, because ETAS models predict probability, but neural networks normally are deterministic model or computational model that don't use this the uncertainty. So we are trying to improve this model in this way. These are some publications that we did with my team, with a student, colleague, and thank you for your attention.
Gracias por la presentación, Orieta. Ahora vamos a invitar a pasar a nuestra investigadora Rosita Yuneman, que también es académica de la Escuela de Ingeniería de la Católica.
¿Se puede ver en pantalla completa? Es... Ahí. Súper, gracias. Bueno, buenas tardes. Yo soy Rosita Yuneman, soy profesora de la Escuela de Ingeniería de la Universidad Católica en el área de Ingeniería Estructural y investigadora de SIGIDEN. Y hoy día les quiero mostrar el resultado de una iniciativa que en la que hemos colaborado hartos investigadores del centro y que tiene que ver con el desarrollo de una plataforma de evaluación de riesgo, en este caso por sismo y tsunami, en ciudades costeras de Chile, y el nombre de la plataforma es Asiste por Sismo, Tsunami, Evacuación. Entonces, antes de partir, me gustaría, igual, a pesar de que hemos hablado mucho de riesgo durante la mañana, ¿cierto?, y estos días, que nos hagamos un poquito la pregunta, ¿qué entendemos por riesgo? Y yo creo que a pesar de todo lo que hemos visto y escuchado y hablado, probablemente todos los que estamos aquí, cuando pensamos en riesgo, pensamos en algo distinto, ¿sí? Puede ser porque venimos de distintas disciplinas o porque entendemos el problema desde otras perspectivas. Para el contexto de lo que yo les quiero contar, creo que es muy importante poder diferenciar el concepto de riesgo del concepto de amenaza, que muchas veces se usan de forma indistinta. Entonces, en ese contexto, lo que vamos a entender en esta presentación, ¿cierto?, por amenaza o peligro, se refiere justamente a la caracterización del fenómeno, que el fenómeno físico que ocurre, ¿cierto?, que en el caso de sismo y tsunami puede ser una medida de intensidad de sismo, la propagación de ondas, la profundidad de inundación del tsunami, pero por otra parte el riesgo intenta caracterizar las consecuencias de esa amenaza. O sea, el riesgo no es la amenaza, sino que son las consecuencias que puede producir eventualmente esa amenaza. Entonces, aquí solamente, a modo, ¿cierto?, de contexto, algunas estadísticas a nivel mundial. No sé si se puede apuntar aquí. Sí, aquí. ¿Cierto? Vemos que por tipo de desastre en el periodo entre 2000 y 2019, vemos el número de muertes según el tipo de desastre, definido así por la ONU, y la cantidad de pérdidas económicas. Entonces, aquí vemos dos formas distintas de caracterizar las consecuencias que podrían producir, por ejemplo, los terremotos, y vemos que en el caso de terremotos y tsunami sigue siendo la causa de la mayor cantidad de muertes a nivel mundial, aunque en términos de pérdidas económicas están un poco más atrás. En nuestro caso, ¿cierto?, en el caso de Chile, solamente en los últimos 15 años hemos tenido 3 eventos de una magnitud mayor a 8 con destructivos tsunamis, ¿cierto? Y eso genera consecuencias de distinto tipo, ¿cierto? Por un lado tenemos damnificados, fallecidos, viviendas afectadas, pérdidas económicas, etc. Entonces, en ese contexto, quisiera volver a que definamos cierto riesgo. Vamos a entender por riesgo la caracterización de las consecuencias de una cierta amenaza, y para poder justamente caracterizar esas consecuencias, básicamente tenemos 3 grandes etapas o 3 grandes elementos para poder cuantificar riesgo. Y son, por un lado, la amenaza. Efectivamente tengo que caracterizar muy bien cuál es el fenómeno, ¿cierto?, que puede producir consecuencias, pero no solamente la amenaza, sino que también tengo que caracterizar la exposición, es decir, cuáles son los elementos, los sistemas que están expuestos a la acción de esa amenaza, ¿cierto? Porque si tengo una alta amenaza sísmica, por ejemplo, en un sitio donde no hay exposición de personas, por supuesto que el riesgo para las personas va a ser muy bajo porque no hay exposición, ¿cierto? Pero además de la exposición, necesitamos entender cómo estos elementos expuestos, en particular yo me voy a referir sobre todo al entorno construido, a las edificaciones, responden o tienen la capacidad de responder frente a una cierta acción de amenaza. Y eso es lo que entendemos en este contexto como vulnerabilidad. Son las condiciones que determinan la capacidad de responder frente a la amenaza. Entonces, estos 3 componentes nos permiten caracterizar las consecuencias de algún fenómeno, y por lo tanto es en estos 3 componentes donde de alguna forma necesitamos concentrarnos para poder caracterizar o cuantificar el riesgo. Ahora, con esa pequeña introducción, ¿cierto?, también es claro y hay consenso en que la planificación urbana o la planificación territorial juega un rol muy relevante en la reducción del riesgo de desastre, básicamente porque justamente tiene un rol significativo en estas 2 etapas, ¿cierto?, en exposición y en vulnerabilidad. De alguna forma, la planificación urbana tiene una incidencia importante en esos 2 aspectos. Y en nuestro caso, en el caso de Chile, efectivamente cada vez que se elabora un instrumento de planificación territorial, que es el que regula el uso de suelo, se requiere un estudio de riesgos, ¿sí? Pero lo que nos dimos cuenta, después de haber ¿cierto?, hecho bastantes análisis, ¿cierto?, es que en su mayoría estos estudios de riesgo evalúan solamente la amenaza. Se llaman estudios de riesgo, pero en general la mayoría solamente evalúa la amenaza. Y la evalúa de distintas formas, ¿cierto? En algunas comunas se cuantifica de una forma, en otras comunas se cuantifica de otra, en algunas se consideran múltiples amenazas, en otras no, etc. Y en definitiva, cada cual un poquito tiene su propio método y herramientas para hacer estos estudios de riesgo. Y no contamos con ninguna herramienta estandarizada para hacerlo, y eso se puede traducir, ¿cierto?, en decisiones distintas, heterogéneas, en el uso de suelo, densificación y restricciones. Entonces, en este contexto, con esa motivación, ¿cierto?, surge Asiste, que es parte de un proyecto FONDEF, pero que surge al interior de SIGIDEN y en el que participan investigadores del centro de distintas disciplinas. que básicamente es una plataforma que busca entregar información sobre riesgo para la planificación urbana, ¿sí? Es una plataforma que permite visualizar algunas métricas de riesgo, considera en su análisis sismo, tsunami y evacuación, está pensada para ciudades costeras en Chile y tiene un piloto, que es el resultado que les voy a mostrar ahora, para la comuna de San Antonio. Y propone un marco conceptual que podría ser extendible, ¿cierto?, a otras comunas de Chile y a otras partes también, y tiene un marco conceptual con un enfoque de evaluación de riesgo probabilístico. Entonces, eso les voy a contar muy brevemente, no quiero ser demasiado latera en este tema, pero solamente para tener en mente de qué se trata o qué es lo que muestra esta herramienta, necesitamos entender un poquito esta metodología de evaluación de riesgo probabilístico. Básicamente tenemos las 3 etapas que yo les acabo de nombrar: amenaza, exposición, vulnerabilidad, para finalmente cuantificar riesgo. Ahora, para llegar a cuantificar riesgo hay muchas formas de hacerlo, ¿sí? También hay muchas formas de caracterizar la amenaza, la exposición y la vulnerabilidad. Por eso es importante entender qué es lo que estamos haciendo en este caso para poder tener claras también cuáles son sus limitaciones y su alcance. En términos de amenaza, lo que nosotros estamos haciendo es simular miles de escenarios de terremotos, ¿sí? Eso nos permite tener o tratar de caracterizar toda la gama de posibles escenarios que podrían ocurrir en un sitio o en una zona, ¿ya? No estamos considerando solamente un escenario de un sismo severo o de un sismo extremo, ese es otro enfoque, ese es un enfoque determinístico. Nosotros estamos usando un enfoque probabilístico en el que estamos considerando miles de simulaciones. En cuanto a la exposición, caracterizamos sobre todo en este estudio las edificaciones expuestas, los edificios, las casas, el entorno construido. Y tenemos una aproximación a la distribución de población. Y en cuanto a la vulnerabilidad, lo que estamos haciendo en este caso es estimar el daño justamente en las edificaciones por sismo y un modelo de evacuación por tsunami, ¿ya? Y por último, integramos todos los resultados y evaluamos el riesgo. Entonces, voy a ir muy rapidito por estas 4 etapas para contarles con un poquito más de detalle lo que estamos haciendo para que se hagan una idea de cómo funciona la plataforma. Entonces, en términos de la amenaza, como les dije, lo primero que hacemos es generar un catálogo de miles de simulaciones de terremotos y eso nos permite calcular lo que nosotros llamamos intensidades sísmicas e intensidades de tsunami para cada uno de esos escenarios. Entonces, ¿qué es lo que hacemos? Básicamente usamos simulaciones de Monte Carlo para generar estos miles de escenarios de terremotos que están definidos por 2 variables, una magnitud, ¿cierto?, que tiene una cierta distribución de acuerdo con los parámetros de recurrencia más o últimos, ¿cierto?, que se han desarrollado para Chile, y los ubicamos espacialmente siguiendo una ubicación con distribución uniforme en el espacio en el que podrían generarse estos eventos. Entonces, para cada uno de estos escenarios, que está definido por una magnitud y una ubicación, vamos a calcular entonces cuáles son las consecuencias de ese escenario y luego al final vamos a integrar las consecuencias de todos los escenarios en esta estimación de riesgo evento por evento. Eso. Bien, entonces para cada escenario, imagínense aquí que tenemos uno de los 60.000 escenarios que tenemos en este caso, para un escenario que tiene una magnitud y una ubicación ahí, por ejemplo, nosotros queremos calcular o estimar las consecuencias aquí en San Antonio, ¿sí? Entonces, lo primero que hacemos es para ese escenario simular o modelar una superficie de ruptura y una distribución de deslizamiento que va a estar en torno, ¿cierto?, a la ubicación del hipocentro. Esto nos va a servir como input para la simulación de intensidades sísmicas en el sitio de interés y también estimamos la deformación en la superficie libre que nos va a servir para simular justamente las intensidades de tsunami. Entonces, una vez que tenemos nuestro modelo de ruptura, nuestra distribución de deslizamiento y nuestra distribución de desplazamiento de la superficie libre, entonces toca estimar, bueno, cuáles son las intensidades de sismo y de tsunami que para ese evento se generarían aquí en San Antonio, ¿sí? Entonces, para eso, en el caso de las intensidades sísmicas, usamos lo que llamamos ground motion models o leyes de atenuación, ¿sí? en que estamos considerando las características del suelo en el sitio, ¿cierto? Y otro tipo de correlaciones entre sitios, ¿cierto? Y también entre medidas de intensidad espectral. Pero en definitiva, lo que logramos con esto, ¿cierto? Este es un modelo empírico que nos permite caracterizar en San Antonio, ¿cierto? Para un evento que se produce aquí, cuáles serían las medidas de intensidad que se esperarían para ese escenario en cada una de las manzanas de la ciudad. Lo mismo para el cálculo de intensidades de tsunami, tomando como input la deformación de la superficie libre, se resuelven estas ecuaciones que no tiene sentido que discutamos, pero que nos permiten generar justamente las medidas de intensidad de tsunami, la profundidad del tsunami y la velocidad del flujo en justamente el sitio de interés que es San Antonio. Entonces, con eso, para cada escenario de este catálogo sintético de terremotos, tenemos intensidades sísmicas e intensidades de tsunami, que además tienen la ventaja de ser consistentes con el mismo evento, ¿sí? Estas medidas de intensidad de sismo con estas medidas de intensidad de tsunami corresponden ambas a este mismo evento. Entonces, una vez que caracterizamos la amenaza, ¿cierto?, queremos caracterizar la exposición, y para eso queremos, por una parte, caracterizar las edificaciones y por otra parte, caracterizar o cuantificar la distribución de población. Entonces, ¿qué es lo que entendemos por el modelo de exposición? Entendemos un modelo georreferenciado, en este caso con un alto nivel de resolución de manzana censal, que nos permite justamente caracterizar lo que está expuesto, las edificaciones. Y para eso tomamos bases de datos públicas, en este caso estamos considerando la base de datos del Servicio de Impuestos Internos, por lo tanto, solo estamos considerando aquellas edificaciones que de alguna u otra forma pagan impuestos, y nos permite caracterizar con un alto nivel de resolución el entorno construido en términos de material de construcción, destino, año de construcción. Nosotros estimamos la altura a partir de la información contenida en la dirección, y eso nos permite identificar aquí en cada manzana la tipología estructural y nivel de diseño. ¿Y por qué nos interesa caracterizar eso? Bueno, porque después las distintas tipologías estructurales van a responder, van a tener una vulnerabilidad distinta frente a la acción de la amenaza. En el caso de San Antonio, ¿cierto?, los resultados de este estudio muestran que predominan las edificaciones de albañilería y madera de baja altura y, en este caso, con un bajo nivel de diseño. A partir de los datos del censo también podemos estimar la distribución de población con el mismo nivel de resolución de manzana censal, y también podemos conocer la distribución por género y por rango etario, que va a ser relevante después para el modelo de evacuación por tsunami. Entonces tenemos amenaza, tenemos exposición. Brevemente voy a definir lo que estamos entendiendo por vulnerabilidad. Ya tenemos, ¿cierto?, caracterizado para cada escenario la medida de intensidad sísmica que podemos esperar en el sitio, ¿cierto? También caracterizamos los elementos que están expuestos en ese sitio, ¿sí? Entonces ahora usamos lo que definimos como curvas de fragilidad, que se definen para una tipología estructural y nivel de diseño, que nos permiten justamente estimar cuál es la probabilidad de que esa estructura esté en un cierto estado de daño, dado una medida de intensidad sísmica. Entonces, como tenemos la intensidad sísmica, tenemos los elementos expuestos, conocemos su curva de fragilidad, entonces podemos estimar el daño por sismo. Así, para cada escenario del catálogo, ¿cierto?, tenemos resultados, por ejemplo, de superficie dañada con distintos niveles de daño en la ciudad. En el caso del tsunami, no tenemos todavía un modelo de daño por tsunami, estamos trabajando en eso, porque para eso necesitamos curvas de fragilidad por tsunami, o sea, entender cómo responden las estructuras frente a una medida de intensidad de tsunami. Estamos trabajando en eso. Lo que hemos hecho por el momento en el caso de tsunami es hacer un modelo de evacuación, que es un modelo de red que incluye la distribución de población y también la congestión, y que permite estimar los tiempos que demoran las personas, según su rango etario, en alcanzar una zona segura, en el fondo, el tiempo que demoran en recorrer, ¿cierto?, la ciudad hasta llegar a la zona segura. Estos resultados después los podemos, ¿cierto?, cruzar con los resultados de tiempos de riesgo de tsunami, y con eso podemos tener una mejor estimación del riesgo por tsunami. De momento estamos trabajando aquí en los tiempos de evacuación solamente. Bien, entonces, hablamos de amenaza, exposición, vulnerabilidad, y ahora entonces lo que hacemos es integrar los resultados de cada uno de los escenarios del catálogo y evaluamos riesgo. ¿Cómo evaluamos el riesgo? Con distintas métricas. Por una parte usamos la tasa de excedencia anual media, o el periodo de retorno promedio, o la probabilidad de excedencia en una ventana de tiempo, ¿ya? Cualquiera de esas tres cosas la obtenemos de la misma forma, ¿cierto? Simplemente a partir de esta expresión en que tenemos todos los miles de escenarios, ¿cierto? Y tenemos los resultados en cada uno de ellos y simplemente nos preguntamos si la variable de consecuencia que queremos analizar superó o no un cierto umbral en cada uno de esos escenarios. Y con eso podemos construir curvas de riesgo. En el caso del riesgo por sismo tenemos curvas por estado de daño en términos de la tasa de excedencia anual o la probabilidad de excedencia en una ventana de tiempo. Y esto aquí yo le estoy mostrando los resultados para toda la ciudad, pero también lo tenemos construido para cada una de las manzanas. Y lo mismo, ¿cierto?, podemos hacer con el caso del tsunami, en que calculamos esta curva de riesgo de personas afectadas por tsunami. Entonces, de alguna forma, esta es la metodología que está detrás de la plataforma, que, como les decía, integra resultados de investigadores del centro y fuera del centro también, el resultado de múltiples investigaciones, y de alguna forma se llevan a esta plataforma de visualización que es Asiste. ¿Cómo voy de tiempo? Ya estoy, que me corto. Ya. Me hubiera gustado mostrarles la plataforma, pero no tengo el computador aquí. Aquí hay solamente algunas láminas, ¿cierto? De momento la plataforma es de uso privado, requiere una identificación con usuario y contraseña. Hoy día quienes tienen acceso a la plataforma son profesionales del Ministerio de Vivienda y Urbanismo, de la Subsecretaría de Desarrollo Regional, de la Municipalidad de San Antonio, que fueron con los que trabajamos en este proyecto. Pero por supuesto que estamos trabajando por poder de alguna forma masificar el uso de la plataforma. ¿Cómo se ve la plataforma? Es básicamente un visor en un mapa, ¿cierto?, que contiene información de 5 módulos, un módulo de exposición, un módulo de amenaza por sismo, de amenaza por tsunami, de riesgo por sismo y de evacuación. Y en cada uno de estos módulos uno puede hacer un montón de cosas y tiene un montón de información. Por ejemplo, en el caso de la exposición, ¿cierto?, se pueden ver en cada manzana los metros cuadrados construidos según el tipo de material, el destino, el año de construcción, etcétera, aquellas variables que nos parezcan relevantes. En términos de amenaza, por ejemplo, se muestran resultados siempre probabilísticos, no mostramos resultados para ningún escenario en particular. Y podemos ver o bien la probabilidad de excedencia, ¿cierto?, o bien el valor de una cierta medida de intensidad sísmica que fuera de interés. Entonces, por ejemplo, ¿cierto?, podemos definir un valor de medida de intensidad, por ejemplo, la aceleración máxima del suelo, que típicamente tiene interés, en una ventana de tiempo de 50 años, y aquí el mapa, ¿cierto?, nos muestra cuál es la probabilidad de excedencia y podemos elegir distintas medidas de intensidad, distintas ventanas de tiempo y, por supuesto, distintos valores. O bien podemos ver, ¿cierto?, por ejemplo, cuál es el valor de la medida de intensidad, en este caso el PGA, que tiene un 10% de probabilidades de ser excedida en 50 años. Entonces es mucha información en términos de amenaza y lo mismo para el módulo de riesgo en términos de que podemos mirar la probabilidad de exceder un cierto superficie dañada, ¿cierto?, con un cierto nivel de daño en una cierta ventana de tiempo, y aquí vemos la probabilidad de excedencia, o bien podemos ver, ¿cierto?, cuál es el porcentaje, por ejemplo, por manzana de superficie con daño completo que tiene un 10% de probabilidad de excedencia en 50 años. Entonces, de alguna forma, tiene otros módulos la plataforma, ¿cierto? No se los puedo mostrar en este minuto, pero ¿qué es lo que hicimos con este proyecto Asiste? Básicamente logramos de alguna forma implementar una metodología de evaluación de riesgo probabilístico acorde con las condiciones locales de Chile, porque tienen las condiciones de sismicidad, de exposición y de vulnerabilidad propias de nuestra zona central, que permite cuantificar de forma, justamente con métricas de riesgo, el riesgo por sismo y tsunami, y que tiene por objetivo ser usada, ¿cierto?, por planificadores urbanos. ¿Y qué es lo que hace? Bueno, evalúa la situación actual, ¿cierto?, en este caso para la ciudad piloto de San Antonio. Entonces, ¿cuáles son las limitaciones? Bueno, hay unas más obvias que otras, ¿cierto?, de este proyecto. Primero, que los resultados son solamente para San Antonio y por supuesto que necesitaríamos algo así para todas las ciudades costeras de Chile, pero eso es costoso computacionalmente. La otra limitación que vimos es que estamos calculando el riesgo por sismo en cuanto a superficie dañada y eso no necesariamente es algo que que sea fácilmente cuantificable para efectos de los planificadores urbanos. Entonces, lo más lógico, ¿cierto?, sería estimar el riesgo en términos de personas afectadas. Estamos evaluando el riesgo por separado, sismo de tsunami. Queremos de alguna forma poder evaluar el riesgo conjunto, ya que tenemos la amenaza conjunta. Y además evaluamos solamente un escenario de exposición. No es posible evaluar escenarios de crecimiento o de densificación de la ciudad. Entonces, por eso surge una segunda etapa de este proyecto, que es otro proyecto FONDEF, en el que también estamos trabajando con el Ministerio de Vivienda y Urbanismo, en que básicamente vamos a extender geográficamente la plataforma, vamos a permitir considerar distintos escenarios de exposición, sobre todo escenarios de distribución de población, por ejemplo, invierno, verano, y distintos escenarios de crecimiento o densificación de la ciudad. Y además queremos trabajar en mejorar nuestro sistema de visualización de información, porque efectivamente, como se muestran hoy día los resultados, a pesar de que se pueden tener muchas métricas de riesgo, podría no ser lo más adecuado para la toma de decisiones, porque es muy complejo todavía. Entonces, de alguna forma queremos trabajar en un sistema que permita hacer una visualización más simple y que permita comunicar de forma más efectiva los resultados de riesgo. Eso es, aquí hay varios de los participantes en este proyecto, así que con eso termino de contarles esto. Muchas gracias. No sé si me extendí demasiado.
Y para dar paso a la última presentación por parte de SIGIDEN, queremos invitar al académico de la Escuela de Diseño de la Católica e investigador del centro, Rodrigo Ramírez.
Well, thanks. Hola a todos, a todas. I'm doing a presentation in English, but surely I will speak more in Spanglish. This is a different presentation. As Gaby told you, I'm a designer, a graphic designer in my background, but specialized in information design. So I'm explaining in this presentation what we are doing with visual tools for managing emergencies. We are talking about design for emergencies. The importance of the emergencies and managing information, the change of paradigm of managing risks from reaction towards management. One case is the Gemini-Icon system that I will explain. We do both the design of these symbols, but also the testing, and how we are applying these elements into the emergency management scenarios, fundamentally working with communities. I am Rodrigo Ramirez. I'm an associate professor at the School of Design, as Gaby told you, researcher at SIGIDEN from 2028, I think, and I am a board member and founder of the Design Network for Emergency Management. An important part of our everyday life is interacting with visual devices, with visual information. Maybe in this room, we will find some elements for signage, or if we look at our mobile phones, for example, we are usually playing with visual elements. These elements are part of our everyday life, but the interaction with information is altered when we enter into an emergency experience. The hypothesis here is that we need to design specifically elements for the emergency experience. It's not a matter of living the normal life, because when we enter into the emergency experience, we are living in a different context. So we are approaching to this from the design of information. So we divide this in this conceptual model of 3 steps: seeing what is visualized, understanding what is comprehended, and then applying the information. What kind of actions will activate this seeing, visualizing, and understanding? Another principle from our project is that these information design principles can be applied into the disaster risk management context. So we have developed this conceptual model about the experience of emergency before, during, and after. Probably people from Taipei yesterday, last night, were in the moment before. They had all the time to prepare for something. Then at 7:30, I think the earthquake came, or the two earthquakes came, so the event was developed from then. So you are changing probably all your mind, all your nature. And then you have the moment after that is a recovery moment. This is what the literature told us. But we have been going beyond that, dividing specifically these moments for information needs. For example, in the moment before managing risks, we can design information for identify the risks, learning about procedures, and activate the preparedness. Then when the event starts, we need to design for actions, for making or taking the right decisions to be safe. And then in the moment after, we are probably focusing on recovery, reporting, articulating, etc. Visual information for emergency is a thing. We are not inventing these elements. You can see different standards around the world, and you can see different applications of that from everyday life, but also for specific moments, like, for example, the Japanese standard for tsunami in the second case. So we have designed this set of symbols. This is the GEML icons for emergency. GEML is a native word. It's from Mapudungun language. It means symbol in one word. The meaning is more intricate, more complicated, but we can say symbol. So we rescue that word in order to show you these elements for before, during, and after emergencies. It is composed by 85 symbols. It's an open source typeface that you can download from our site, and you can install it in your computer. You can install it in your systems. So we are replacing all these alphabetical keyboards into different symbols. It's nothing new, again. It's just a matter of a Dingbats typeface or a font that you can enter, and you can download it and install it to use in your own systems. But we are going beyond the visual design, not just proposing new shapes for managing the emergencies. So we are continually testing the symbols, what these symbols means for different communities, for different populations, for different languages. We have tried testings in Chinese, for example. We have tried different testings in different languages and with different communities, activating also, as you can see here at the right, some communal or community working with, in this case, a population from Cartagena. We ran two different tests. This is the methodological part. One is the preferences test. It's, again, the application of worldwide instruments, asking respondents about which of these two options does represent, for example, in this case, evacuation way. So you can see, and you can just choose which of these elements, probably both or one of them, can tell you the right preference. So we take all that data and we systematize and analyze the responses. And the test at the right that you can make it now, if you have your mobile phone here, following with the QR code, is the meaning test. We are asking a very simple question: what does this icon represent? And we collect open responses. So I'm explaining a little bit more here. We have the representation. We collect 200 responses per each icon. Then we categorize following an international procedure. And then we have an indicator. So we know now, after 5 rounds of testing with near 20,000 responses around the world, which of these icons are more effective or are telling you the right representation or the right interpretation. So here you can see, for example, for different icons, some of them, the responses are not wrong. People interpret their world, their representations, using different words. So this is like a natural language. I'm just telling you what I'm seeing, so we collect then, and we can, of course, make patterns about the responses that are more repeated, for example. And then, at the left, we can see how the different rounds give us the opportunity to improve the quality of the icons. Some of them have been make very little adjustments or elements that reveal more clarity for a common person that is seeing a signage, for example. And at the right, you can see this is the last test that we ran last year in 2023, when we asked people with these different elements. In the preferences test, I didn't mention before that we can also put some of the current signage or symbols that are being used. So we are, for example, in this case, using some symbols from the UN, the Office of Humanitarian Affairs. They have their own symbol standard, so we integrate this in order to compare which of them are more preferred from common people. And then, after the symbols, design, and testing, we are using the symbols also to activate communities. We like very much to call it that. Beyond the ability of drawing or making nice elements in the space. We are running a set of workshops with communities. Here you can see a sequence from Cartagena. This is using an exercise called the Disaster Imagination Game. You use a map, it's a participatory mapping exercise, but the icons are giving you the chance to put your keys, to put your files. Where are you deciding, where are the points that you are discussing more, for example? We ran, during the pandemics, sets of virtual workshops, working with different communities, and also with, then in 2022, with schools through SIGIDEN. This is also an international opportunity because I didn't mention before, but symbols usually are considered the universal language. We are discovering in our research that are not universal. You can interpret according with your cultural background, with your language, with your familiarity with the scenarios, but we use these symbols to going to China, for example, and work with design students there, and this year in March, working with also students of the School of Design of University of Palermo in Italy. We have developed a set of very simple pieces. We call it these info kits. We started to develop these pieces during pandemics in order to represent some specific scenarios, but adding also some texts. And then we came involved in a collaborative translation of that elements, giving people from Rapa Nui in Easter Island, or Mapudungun in the southern part of Argentina and Chile, Totonaco in Mexico, Quechua in Peru and Bolivia, Creole in Haiti, the chance to translate that visual information into their own text. And we have discovered, of course, that this very simple exercise of translating the meaning into their own language is creating a lot more of involvement in the process of risk management. We are experimenting and redefining applications, for example, with these pieces that mix some narratives with symbols in order to create scenarios to tell people with very simple elements about the scenario of a tsunami, for example. Observe, evacuate, wait. These are the scenes that you then develop as symbols. Then, at the center, you can see one scenario about a volcanic emergency, and then vertical evacuation and heat waves. Of course, in these applications of the symbols, we are collaborating with a lot of different researchers from SIGIDEN. And we also make crazy experiments, like, for example, putting these elements into WhatsApp or Telegram stickers just to send and share and see what happens if we are viralizing these elements. Working with a team in the University of Valparaíso, the group Marejadas, we are also working this kind of thermometer of different sea tides or sea surges. Sea surges, the Marejadas. And of course, exploring, for example, the incidence, the meaning, and the effectivity of these elements if we are putting into micro animations. How are you prepared, or make a kit of emergency is simple. And as I told you before, just making different experiments for COVID or pandemics, sea tides, vertical evacuations, and fires. This is our last experiments this year. This is an instance open for collaboration, so if anyone here in this room, si cualquiera de ustedes quiere en algún momento contactarnos, colaborar a través de SIGIDEN, nosotros estamos siempre, we are always working with different researchers and teams in this process. One example, just to finish, coming from the design school, we opened this line of working, this research line, research and development line, about how we can apply design into the emergency scenario. So you can see here the work from students is a selection, and if you want to see the 85 projects that we are developing together with SIGIDEN, this is the site, d4rs.info, when you can see the different design projects that the students are currently working in different semesters in our school. So, Miji, gracias, y we are in touch.
Gracias a las y los investigadores de SIGIDEN por sus valiosas presentaciones. Nuevamente, gracias también a las científicas y científicos de QuakeCore, y en particular a todas y todos los presentes y también a las personas que están conectadas en nuestro canal de YouTube. Afuera también quiero invitarles que hay un stand de Ediciones UC por si quieren adquirir el libro Ciencia con Impacto. Y bueno, damos las gracias y por cerrado también este seminario.